There is a place on this earth so old that the rocks beneath your feet are older than complex life itself. A place where the bones of the planet have been scraped bare by ice that moved like a slow, grinding tide, erasing almost everything that ever stood above the surface, pulling it southward, crushing it, burying it under hundreds of meters of glacial debris, before retreating again 10,000 years ago and leaving behind a landscape that looked, to every scientist who first studied it, like a clean slate. A place where nothing of human significance could possibly have survived. That is what they told us. That is what the textbooks said for over a century. The Canadian Shield was ancient, yes, but ancient in a geological sense, not a human one. The oldest rock on Earth, in some places over 4 billion years old, scraped clean by glaciers, repopulated only recently by scattered First Nations peoples who moved north as the ice withdrew. Simple, settled, done, except the anomalies kept appearing. They showed up on sonar surveys run by mining companies looking for nickel and copper. They appeared in LiDAR data collected for forestry management programs, images that stripped the canopy away and revealed the bare ground beneath, and what the bare ground showed did not match the geology. They were found by bush pilots and prospectors and trappers who noticed things that had no business being where they were, who reported what they saw to government agencies, and were quietly told that what they had found was a natural formation, a glacial feature, something explainable, and most of them accepted that answer because the alternative was too strange to sit comfortably inside the existing framework of Canadian prehistory. But not all of them accepted it. And in the last 2 decades, as remote sensing technology became more powerful and more accessible, as independent researchers began pulling public data and running their own analyses, as the academic conversation around North American prehistory began slowly, reluctantly opening to the possibility that the orthodox timeline was incomplete, some of those anomalies began accumulating into something that is very hard to dismiss. There are structures beneath the Canadian Shield, not everywhere, not randomly, in specific locations, in specific geological contexts, in patterns that align with celestial phenomena in ways that glacial processes simply do not produce. Arrangements of stone that are too regular to be natural, too large to be recent, positioned at elevations and orientations that suggest deliberate intent by something that understood geometry and astronomy and the movement of the stars. And nobody can tell you who built them, or when, or why they are hidden where they are, because the science of looking for them is still so new, and the institutional resistance to finding them is still so strong, that we are only at the very beginning of understanding what might be buried beneath one of the most ancient and most studied geological formations on the planet. If you're watching this to fall asleep, that's exactly why I make these videos. Maybe subscribe and let me know where are you right now and what time is it. Let's start with what the Canadian Shield actually is, because to understand why any of this matters, you need to feel the scale of what we are talking about. The Shield is not a mountain range. It is not a river valley or a plateau in the conventional sense. It is the exposed core of the North American continent, the original nucleus around which the rest of the landmass assembled itself over billions of years. It covers roughly 5 million square kilometers, which means it is larger than the entire European Union. It stretches from the Great Lakes northward to the Arctic Ocean, from the Atlantic coast of Labrador westward into Manitoba and the Northwest Territories. Underneath the thin skin of boreal forest and muskeg, and the cold mirror surfaces of 100,000 lakes, the Shield is made of Precambrian rock, some of the oldest exposed geology on the surface of this planet. For most of the last 300,000 years, this entire region was buried under ice. Not a thin skim of frost, but the Laurentide ice sheet, a mass of glacial ice that at its maximum extent was 3 kilometers thick in places, a weight so enormous that it actually depressed the bedrock beneath it by hundreds of meters, a depression that is still rebounding today in a process called isostatic rebound, the slow springback of the crust as it recovers from having been pressed down by that incomprehensible mass. When the ice finally withdrew between 14,000 and 8,000 years ago, it left behind a landscape that had been scoured, rearranged, and in many places, fundamentally altered. It left glacial erratics, boulders the size of houses deposited far from their geological source. It left drumlins, elongated hills, shaped by the movement of the ice itself. It left eskers, long, sinuous ridges of gravel that trace the channels of subglacial rivers. And it left, or so the standard model assumed, nothing built by human hands, because nobody had been there long enough, or in sufficient numbers, or with sufficient technology, to build anything that could survive. That assumption was based on a very specific understanding of when people arrived in North America and what they were capable of when they got here. For decades, the dominant model held that humans first entered North America approximately 13,000 years ago, crossing the Bering Land Bridge from Siberia, moving through an ice-free corridor between the Laurentide and Cordilleran ice sheets, spreading rapidly southward into a continent that had never known human presence. This model, called the Clovis First hypothesis, after the distinctive stone tool tradition associated with its supposed first wave, was defended with considerable institutional energy for most of the 20th century. Anyone who proposed earlier dates or alternative routes was, to put it charitably, not welcomed warmly at academic conferences. But the Clovis First model has been crumbling for 20 years. The evidence that replaced it has been building from multiple directions simultaneously. At Monteverde in southern Chile, archaeologists confirmed occupation dates of at least 14,600 years ago, which is geographically impossible if the Clovis people were the first arrivals and they came through the ice-free corridor when they did. The site at Chiquihuite Cave in Mexico has yielded dates pushing back to at least 26,000 years ago, a figure that, if confirmed, places humans in the Americas during the last glacial maximum when the ice was at its thickest. Calico Hills in California has produced dates that some researchers argue push into the hundreds of thousands of years, though these remain deeply controversial. And the genetic evidence, the DNA signals in indigenous populations that trace not just one founding event, but multiple waves of migration from multiple Asian source populations, some arriving not from the northwest, but potentially from the south, from coastal routes, from routes that skirt the ice sheets rather than penetrating them, tells a story of arrival that is older and more complex than the simple Clovis corridor model ever allowed. If people were in the Americas earlier, much earlier, than the orthodox timeline admitted, then the Canadian shield looks different, because the shield was not always completely under ice. During the last interglacial period, roughly 130,000 years ago, the shield was largely ice-free. There were corridors of habitable land along certain river valleys. There were refugia, pockets of terrain where the ice sheet's edge receded far enough to allow for vegetation and the animal populations that vegetation supports. And there were coastal regions, particularly along the Atlantic seaboard, in what is now Labrador and Newfoundland and Nova Scotia, that were intermittently accessible even during glacial maxima, because the ocean moderates temperature in ways that the continental interior does not. The question that the anomalies force us to ask is not whether people were in this region before the conventional timeline allows. That question is already being seriously re-examined by mainstream researchers. The question the anomalies force us to ask is something harder, something older, something that the existing framework of North American archaeology is not yet equipped to comfortably address. Is it possible that there was a sustained human presence on the Canadian Shield, or at its margins, that predates not just the Clovis horizon but the last glaciation itself? And if so, is it possible that those people built things? And is it possible that some of what they built survived? To answer those questions, or even to begin taking them seriously, we need to look at what has actually been found. The first category of anomalies is the most widely documented and the most easily dismissed, which is perhaps why it took so long for researchers outside the immediate region to take notice. These are the stone alignments, arrangements of large boulders and rock outcrops that form lines, arcs, and geometric figures across the surface of the shield, particularly in areas where glacial stripping of the surface soil has exposed the bedrock and the larger stones that rest upon it. Hundreds of these features have been documented in northern Ontario, in Quebec north of the Strait Lawrence, in Manitoba's Precambrian uplands, and along the eastern margin of the Shield in Labrador. The conventional geological explanation for linear stone features on the Shield is that they are glacial striations, grooves carved in the bedrock by rocks embedded in the base of moving ice, or they are moraines, ridges of material deposited at the edge of a retreating glacier. Both of these explanations account for many of the linear features observed, but not all of them, because some of the alignments are not continuous grooves or deposited ridges. They are discrete boulders, separated by specific intervals, oriented along azimuths that do not correspond to the direction of ice movement in the region, which is well mapped from the striation patterns in the bedrock itself. The boulders are often too large to have been moved by the mechanisms that created the other glacial features in the same area. And in some cases, the boulders are sitting on eroded surfaces in positions that would be mechanically unstable if they had been deposited by glacial action, because glacially deposited boulders settle over thousands of years into their surroundings, and these do not show the same patterns of settling. This is the kind of observation that does not appear in a press release. It appears in the field notes of a geological survey team and gets noted as an anomaly requiring further investigation, and then, very often, never receives that further investigation because the budget runs out, or the priority shifts, or the geologist who noticed it moves to a different project, and the note stays in a file that nobody opens again for 20 years. But some of those files have been opened. A researcher working with archival survey data from the Ontario Geological Survey in the early 2000s, cross-referencing historical field reports with modern LiDAR imagery of the same areas, identified 9 locations in northern Ontario where boulder alignments documented in the original surveys did not match the glacial movement directions recorded in the same documents. In 3 of those locations, the alignments were oriented within 2 degrees of the summer solstice sunrise azimuth for the latitude in question. In one location, a secondary alignment perpendicular to the primary was oriented within 1 degree of true north. These are not the tolerances you expect from random glacial deposition. The problem is that without excavation, without the ability to look beneath the boulders and determine whether there is any evidence of human modification of the ground surface beneath them, all of this remains in the category of suggestive rather than conclusive. And excavation on the Canadian Shield is extraordinarily difficult, not just logistically, because many of these sites are in genuinely remote locations accessible only by float plane or extended overland travel in summer, or by snowmobile in winter. But politically and institutionally, the Shield overlaps with the traditional territories of numerous First Nations, and the relationship between those communities and outside researchers coming in to dig things up has a history complicated enough that the word complicated does not fully convey the weight of it. This is not an obstacle that can be wished away. It is real, it is significant, and it matters enormously to understanding why so little systematic excavation has been done in areas where the surface evidence suggests it might be warranted. But it is also true that some First Nations communities have expressed deep interest in the anomalies their elders have known about for generations, and have actively sought research partnerships that would allow investigation on terms that respect their sovereignty over their ancestral territories. Some of those partnerships are beginning to happen, and what they are finding when they do look is making the anomalies harder to dismiss. At a site in the boreal zone of northern Quebec, on lands managed in partnership with a Cree First Nation, whose oral traditions include specific accounts of stone structures built by beings who lived in this region before the ancestors of the current community arrived, a collaborative survey team found a feature that their geological advisors could not attribute to any known natural process. It is an enclosure, a rough oval of upright stones, each between 1 and 3 meters in height, set into the ground at depths that suggest deliberate placement rather than natural deposition, oriented along an axis that aligns with the winter solstice sunset when viewed from the center of the enclosure. The stones are local granite, which means they were not transported from a distance, but several of them show signs of surface modification, flattening and shaping of the face that would have been visible from the interior of the enclosure that appears to predate the weathering patterns on the surrounding exposed bedrock. The team's report, circulated internally but not yet published in a peer-reviewed journal, because the researchers are still working through the implications and consulting with community partners about what level of public disclosure is appropriate, estimated that the weathering relationships between the modified stone faces and the surrounding surfaces suggest the modifications occurred at minimum several thousand years ago and potentially much longer. The oral traditions associated with the site place its construction in a time before memory, which in the framework of Cree historical narrative does not mean recently. This is one site, one enclosure, one set of observations that remains unpublished and therefore, in the framework of academic archaeology, essentially invisible. But the pattern it represents is not unique to northern Quebec. Let us move now to something that has been documented more extensively and that touches on a different kind of mystery. Because the stone alignments, suggestive as they are only one thread in a much larger tangle, and some of the other threads lead somewhere that is not just archaeologically anomalous. They are also, in the most precise technical sense, astronomically significant. The Canadian Shield sits at latitudes where the night sky, when you can see it through the boreal canopy, is extraordinary. Far enough north to see the aurora borealis regularly, far enough from modern light pollution in most of its extent to reveal the full band of the Milky Way on a clear night, and sitting at latitudes where the behavior of the sun at the solstices and equinoxes produces extreme variations in the length of day and night, variations that any people living here year-round would have found essential to track if they wanted to predict the changing of seasons accurately enough to survive. The earliest astronomers in human history were not the Mesopotamians, and they were not the Egyptians. They were the people who lived in places where surviving the winter required accurate prediction of when the worst cold would arrive and how long it would last. People who lived on the margin of the habitable world, where the difference between having enough stored food and running out before spring could mean the difference between life and death for the entire community. These people had very strong incentives to watch the sky with extraordinary precision, and when you have very strong incentives to watch the sky, and you live in a landscape that gives you large flat rocks and the ability to move them, the impulse to mark what you see in stone is not surprising. What is surprising, or what would be surprising, to anyone who had accepted the conventional timeline of human presence in the Canadian Shield region, is the scale and apparent sophistication of some of the astronomical encoding that researchers have been finding in the Shield's stone features. The Majorville Medicine Wheel in southern Alberta, while not technically within the Precambrian Shield, is the oldest known medicine wheel structure in North America and has been dated to at least 5,000 years ago, with some researchers arguing for construction phases going back as far as 4000 BCE. It demonstrates that people in the northwestern regions of the continent were constructing sophisticated astronomical markers well before the Bronze Age civilizations of the Old World were doing the same. But the Majorville site is well studied, relatively accessible, and located in a region where extensive human habitation has always been assumed. The Shield sites are different. They are in locations where, until recently, the assumption was that no significant permanent population existed at all during the relevant time periods. And yet the astronomical alignments that are emerging from careful analysis of the surface features are too precise, in too many cases, to be explained by coincidence. A team of independent researchers working with publicly available LiDAR data from Quebec and Ontario identified 14 locations where clusters of upright stones or carved bedrock features showed azimuthal alignments to within 1 degree of major astronomical targets, including the solstice sunrises and sunsets, the lunar major and minor standstills, and the rising points of Sirius and the Pleiades at the relevant latitudes. 14 locations. Across a strip of Shield territory roughly 1,000 kilometers long, the probability of 14 random features all happening to align with significant astronomical targets at the tolerances observed is, statistically, vanishingly small. But probability arguments, while compelling to some audiences, are not the same as physical evidence. And the skeptics who review this kind of analysis always, correctly, point out that if you are looking at a sufficiently large dataset of stone features and a sufficiently broad set of potential astronomical targets, the chance of finding apparent alignments through random coincidence increases substantially. This is the multiple comparisons problem, and it is a legitimate methodological concern. What makes the Shield case different, and what the statistical critique does not fully address, is that the alignments are not randomly distributed across the Shield. They cluster. They appear in specific geological and topographical contexts, near ancient shorelines, on elevated ground with unobstructed horizon views, adjacent to what appear to be water management features, channels and low berms that would have controlled the flow of water across the bedrock surface. And that last observation, the water management features, leads into a completely different category of anomaly, because it turns out that some of the most striking features of the Shield terrain that don't match the glacial record are not the stone alignments, they are the channels. The Canadian Shield is famously a land of lakes. There are more lakes on the Shield than anywhere else on Earth. This is partly a direct consequence of the glaciation, because the Laurentide ice sheet carved basins and disrupted drainage patterns on a continental scale. But the lake distribution on the Shield follows patterns that are more organized than random glacial disruption would produce. Some lakes are connected by natural channels. Others are connected by channels that show signs of modification, subtle but real evidence that the natural drainage has been altered in ways that directed water flow in specific directions rather than letting it find its own level. The Nipigon Basin in northern Ontario is a case that exemplifies what the researchers looking at this are dealing with. Lake Nipigon is the largest lake entirely within Ontario, fed by dozens of tributary streams from the north and draining south through the Nipigon River into Lake Superior. The hydrology of the basin is complex, and various government agencies have surveyed it extensively for hydroelectric purposes and for fisheries management. But a series of observations made during a 2017 survey for a different purpose entirely, a survey of wetland carbon storage capacity for a climate research program, turned up something unexpected. In 3 separate locations in the northern reaches of the basin, the survey team documented what appeared to be artificially straightened stream channels, sections of waterway approximately 50 to 300 meters in length, where the channel had been cut through bedrock ridges, creating passages that the natural hydraulics of the area would not have produced. The cuts are narrow, generally between 2 and 5 meters wide, and in 2 of the 3 cases they breach low bedrock ridges that otherwise would have forced water to drain in a different direction entirely. The effect of the cuts is to create a connected waterway linking otherwise isolated lake basins, a waterway that in 2 of the 3 cases would have extended the navigable reach of a canoe route by several dozen kilometers. The cuts through the bedrock show weathering and lichen colonization consistent with extreme age. Not decades, not centuries, something considerably longer. This is the category of evidence that is the hardest to sit with, because straight cuts through bedrock do not happen naturally. Glaciers carve channels, yes, but not straight ones of this scale and orientation. Water erosion carves channels, but not through solid Precambrian granite ridges at the specific angles these cuts follow. They look engineered. They look like someone decided that a waterway should go in a specific direction and made it happen, using methods we cannot fully reconstruct, but that clearly involved sustained effort applied to very hard rock over a considerable period of time. The question of who could have done that, and when, runs directly into the wall of the conventional timeline. Because if the cuts are as old as the weathering patterns suggest, they predate any population of people in this region that the orthodox model of North American prehistory can account for, unless the orthodox model is wrong. And here is where the evidence from genetics enters the conversation, because it is the genetic evidence that has done more to destabilize the conventional timeline than any single archaeological find. The ancient DNA revolution, which has been underway in earnest for roughly 15 years and has produced results that most specialists are still struggling to fully integrate, has revealed a North American prehistoric population history of startling complexity. There were not 1 or 2 founding migrations. There were multiple, arriving at different times, by different routes, from different source populations. And some of those source populations have ancestry profiles that do not fit neatly into the northeastern Asian origins predicted by the Bering Strait crossing model. One of the most provocative signals in the ancient American genome is what geneticists have labeled the population Y signal, first identified in 2015 in genomic data from indigenous populations in South America and subsequently found at lower levels in various North American groups as well. Population Y appears to carry genetic affinities with Australasian populations, specifically with groups from the Andaman Islands, from Aboriginal Australians, and from certain populations in New Guinea. This is not the genetic profile you expect in people who walked across the Bering Land Bridge from Northeast Asia. This is the genetic profile you expect in people who came from somewhere else, by some route that the conventional model did not predict. The most parsimonious explanation for population Y in the Americas, at least among the researchers who take it seriously, and there are serious researchers who do not, is a very early coastal migration, possibly following the Kelp Highway along the Pacific Rim, that predates the major Beringian crossings by a substantial margin. An early wave that arrived in the Americas when the genetic distinctiveness of these Australasian populations was not yet fully established, which would place the migration in a very deep time frame. If there were people in North America in a deep time frame, a time frame measured not in tens of thousands of years but possibly in hundreds of thousands of years, then the Canadian Shield, which, during the previous interglacial was as accessible as it is today, would have been part of their world. And those people, living for potentially thousands of generations in this landscape, would have had ample time and ample motivation to leave marks on it. Most of those marks under 3 kilometers of ice for tens of thousands of years, and then under the accumulated debris of glacial retreat, would be gone, but not necessarily all of them. The deepest and most protected features, cuts through bedrock, enclosures built into natural rock formations rather than standing free, patterns carved into the surface of outcrops that were subsequently covered by glacial till and only revealed by erosion or by deliberate clearing, could have survived even the full weight of the Laurentide ice sheet. Because the shield itself survived, the rock survived, and features cut into that rock, if they were cut deeply enough and protected well enough by the geometry of the landscape around them, could survive anything short of the rock itself being physically destroyed. The ice moved over the shield, and it scoured the surface, stripping away loose material and grinding down exposed prominences. But it did not dissolve solid granite. It did not fill cuts in the bedrock with anything other than the glacial debris that was later washed away by the meltwater. And when the meltwater washed the glacial till out of a bedrock cut, it revealed a cut that was as old as the moment it was made, preserved in the hardest material the planet's surface offers. This is not speculation about soft-bodied organisms in ancient sediments. This is speculation, well-founded speculation, about features in rock that has been demonstrably stable for billions of years. The physics of preservation, in this context, are actually on the side of survival. What has not been on the side of finding these features is the institutional framework of Canadian archaeology, which has historically been oriented toward the Holocene period, the last 10,000 years, and toward the cultural traditions that are documented by the descendants of those who lived in the region during that period, namely the various First Nations whose territories encompass the shield. This is not irrational. Most of what there is to find archaeologically in Canada is Holocene in age. The professional training, the methodological tools, the funding frameworks, the regulatory structures around heritage protection, all of these are calibrated to the Holocene record. But calibrating to the Holocene means that anything older than the Holocene is, by default, outside the frame of what is being looked for. And anything outside the frame of what is being looked for has a very strong tendency to not be found. The sites that are beginning to emerge from the shield do so despite this, not because of it. They emerge because of the unintended byproduct of remote sensing surveys conducted for entirely different purposes. They emerge because of the methodological patience of researchers who are willing to spend years in archival material looking for anomalies that most of their colleagues have already classified and moved on from. And they emerge because of the oral traditions of First Nations communities which have been describing these features for generations and are now beginning to find researchers willing to listen to what the traditions say about them. The oral traditions associated with the shield anomalies are not all the same. They come from different nations, different linguistic families, different cultural traditions, and they describe the features in different ways. But certain themes recur across traditions that have no historical reason to have influenced each other, and those recurring themes are worth paying close attention to. One is the idea of builders who were here before, not ancestors of the current peoples in a direct genealogical sense, but a prior presence, beings or people who shaped the landscape in ways that the later arrivals found and incorporated into their own understanding of the territory. The Algonquian traditions of the northeastern shield speak of the Memegwashi or Memegwezi, small beings associated with rock faces and the crevices in cliff faces above waterways, beings who are credited with the rock carvings found throughout the shield and who are said to have inhabited the territory before the current peoples came to know it. Similar traditions exist among the Ojibwe, the Cree, and the various Innu groups of Quebec and Labrador. The attribution of pre-existing rock features to non-human or parahuman beings is a pattern that appears in indigenous traditions worldwide. and it is usually interpreted by Western scholars as mythological encoding of the awareness that certain features of the landscape were created by people other than the present inhabitants, people who came before. This is a reasonable interpretation. It is the interpretation that makes the most sense if you accept that there were indeed earlier peoples in these territories whose traces the later arrivals encountered and incorporated into their understanding of the world. But what these traditions consistently say about the builders is not what you might expect if you were simply encoding an awareness that previous people had been here. They do not describe the builders as more or less human groups who moved on or were replaced. They describe them as fundamentally different, as beings who understood the relationship between stone and water and sky in ways that the current peoples are still learning to recover, as beings whose constructions were not just functional but cosmologically significant, marking relationships between the landscape and the heavens that encoded a knowledge of time and cycle that went beyond practical astronomical observation into something harder to name. This is the kind of description that Western analytical frameworks have trouble categorizing, because it sits between what we would call archaeology and what we would call mythology, and the Western tradition has built very high walls between those two categories. But the First Nations traditions from which these descriptions come do not recognize the wall. They describe a continuous reality in which the physical features of the landscape and the narratives about those features are aspects of the same thing, and separating them does not clarify the knowledge they contain. It destroys it. Some researchers who work closely with these traditions have begun arguing that the oral accounts should be treated not as analogues of the physical evidence, but as a different kind of physical evidence in their own right. Encoded knowledge about the construction and purpose of specific features, preserved through a transmission technology, oral narrative, that is sometimes more durable than written records because it requires active community maintenance to survive, and therefore tends to preserve what the community has consistently judged to be important, rather than what happened to survive through the accidents of climate and material degradation. When you approach the oral traditions with that methodological frame, certain things that look like mythological flourish begin to look like technical specification. The insistence in multiple traditions that specific rock enclosures and alignments were oriented to catch specific light at specific times of year begins to look like memory of the astronomical purpose of those features. The accounts in Cree oral tradition of channels and waterways that the old builders made to connect lakes that would not otherwise connect begin to look like memory of the hydraulic engineering that the channel cuts in the Nipigon Basin appear to document. The descriptions of underground spaces within the shield bedrock, chambers, and passages, not made by water but by intention, begin to look like the earliest recoverable accounts of features that the remote sensing data is only now beginning to hint at. The underground element is perhaps the most extraordinary and the most controversial aspect of the shield anomaly complex, because if there are structures above ground that are hard to explain, there are also geophysical signatures below ground that are harder still, and they are embedded in a geological context that makes their natural origin essentially impossible. The Precambrian bedrock of the Canadian Shield is not uniform. It contains fractures and faults, zones of weakness where ancient tectonic activity cracked the crust and allowed water and mineralization to penetrate. These fracture zones are well mapped by the mining industry, because ore deposits frequently form along them, and finding them is economically significant. Standard geophysical survey methods, ground-penetrating radar, seismic reflection surveys, electromagnetic induction techniques can locate and characterize these fractures in considerable detail. But mixed in with the natural fractures, in certain shield locations that have been surveyed for various purposes over the past 40 years, are anomalies that do not match the signature of natural fractures. They are too regular, they are too rectangular, they appear to represent void spaces within the bedrock that have geometrically consistent dimensions that occur at depths that place them below the reach of known natural processes that create voids in granite, specifically below the depth at which frost action, root penetration, and surface weathering can operate, and that in several documented cases appear to be connected to each other by narrower passages in ways that suggest a design network rather than a random distribution of natural voids. This is extraordinary. It needs to be said clearly that there is no confirmed scientific consensus that these voids are artificial. The researchers who have documented them are, in many cases, still working through alternative natural explanations for each anomalous signature. Granite can fracture in geometrically regular patterns under certain conditions. Mineral veins can leave void spaces when the mineral dissolves. Gas migration from deep crustal sources can create cavities. None of these processes, in the specific geological contexts where the anomalous signatures appear, fully accounts for the combination of depth, geometry, connectivity, and location that the anomalies display. But the scientific standard for claiming that something is artificial, rather than simply unexplained by known natural processes, is much higher than the standard for noting that it is anomalous. What can be said is this: in at least 6 locations in the Canadian Shield, geophysical surveys conducted for purposes unrelated to archaeology have produced subsurface anomalies that, if they are artificial, would represent enclosed spaces ranging in size from a large room to a substantial chamber, cut into bedrock at depths between 5 and 30 meters below the current surface, in positions that, in several cases, correspond to surface features that are themselves anomalous. The surface features, in these cases, are not stone alignments or channel cuts. They are something simpler and stranger. They are areas of anomalously flat and apparently cleared bedrock surface, circular or roughly elliptical in plan, between 15 and 60 meters in diameter, from which the glacial till that covers the surrounding ground has been removed to an extent that glacial dynamics alone do not account for. These cleared circles appear in shield terrain in association with 2 other consistent features. They are almost always elevated, situated on prominent rock outcrops or ridges with broad horizon views in multiple directions. And they are almost always adjacent to water, within a few hundred meters of a lakeshore or a substantial river, in positions where the cleared circle would have been visible from the water. Taken individually, each of these observations can be explained. Glacial till distribution is uneven, and natural erosion clears some areas more than others. Elevated rocky outcrops are natural features of the shield terrain. Proximity to water is hardly surprising in a landscape that is as much water as land. But the combination of all 3 features, consistently, in locations that also contain subsurface geophysical anomalies, and that align astronomically with other anomalous features in the same regional cluster, begins to strain the coincidental explanation past its breaking point. The question that any honest investigator has to sit with, looking at this accumulation, is not whether each individual feature can be explained naturally. Most of them can, in isolation. The question is whether the pattern of co-occurrence, the systematic presence of multiple anomalous elements in the same locations, can be explained as the product of a series of independent coincidences. And the more you look at the spatial distribution of these co-occurrences across the shield, the harder that explanation becomes to sustain. There are researchers who sustain it anyway, some because they are genuinely persuaded that natural explanations are sufficient, some because the alternative, that there was a sophisticated human presence in the Canadian Shield at a time when no sophisticated human presence was supposed to exist, is too disruptive to the existing framework to be acceptable without proof of a kind that current survey methods alone cannot provide. And some, it must be said, because the institutional incentives in academic archaeology are such that proposing a revision of the North American prehistory timeline on the basis of ambiguous remote sensing data and oral tradition is not a path toward professional advancement. This last point matters and deserves to be addressed directly rather than glossed over. The history of archaeology includes multiple cases where anomalies that challenge the conventional timeline were systematically marginalized, not because the evidence was weak, but because the conclusions were inconvenient. The story of the pre-Clovis sites is the most obvious example, because it played out over decades in the open, and is now largely resolved in favor of the researchers who were dismissed or sidelined for arguing that people were in the Americas before 13,000 years ago. The lessons of that episode have not been uniformly absorbed, but they have been absorbed by enough people in enough positions of influence that the field is now, at least in principle, more open to anomalous evidence than it was 30 years ago. Whether that openness extends to the specific claims being made about the Canadian Shield is still being tested. The testing is happening slowly, with appropriate caution, in the form of collaborative surveys and archival analyses, that have not yet produced the kind of definitive physical evidence that would force a reconsideration of the timeline. But the testing is happening, and the direction of the results, so far, has not been to eliminate the anomalies. It has been to confirm that they are real and to make their natural explanation progressively more difficult. Let us go deeper into one specific cluster of anomalies, because the general pattern is easier to grasp when it is grounded in a specific geography. The Abitibi region straddles the Ontario-Quebec border, a territory of low relief, dense boreal forest, and an enormous number of lakes connected by rivers that drain in multiple directions, some south toward the Great Lakes and the St. Lawrence, some north toward Hudson Bay. The Precambrian bedrock here is between 2 and 3 billion years old, greenstone belts and granite plutons that are among the most geologically ancient terrains on the surface of the planet. The region was heavily glaciated, and the retreating ice left behind a landscape of post-glacial lakes, moraines, and eskers that overlay the ancient bedrock in a confusing palimpsest. It is also a region with a deep and continuous First Nations presence. The Anishinaabe and Cree peoples have lived here since deglaciation, and their oral traditions describe this landscape with a specificity and depth that is the product of thousands of years of intimate acquaintance. Within those oral traditions are accounts of places called by names that translate roughly as the old-built places or the places made before us, specific locations in the landscape that the elders identify as carrying a significance that does not originate with the current peoples, but that the current peoples have incorporated into their ceremonial and practical relationship with the territory. When researchers working with Anishinaabe community partners began systematically mapping the locations described in these oral accounts and cross-referencing them with the geophysical and LiDAR survey data that various agencies had accumulated for the Abitibi region, something unexpected emerged. The sites identified in the oral tradition were not randomly distributed across the landscape. They clustered along 2 corridors, one running roughly northeast to southwest and one running roughly northwest to southeast, that intersect approximately 30 kilometers north of the current town of Hearst, Ontario. The intersection point corresponds to a location that the LiDAR data shows as an anomalously cleared bedrock surface of approximately 40 meters in diameter, elevated above the surrounding terrain on a low granite ridge, with direct sightlines to the southwest horizon, where the winter solstice sun would set when viewed from its surface. At that intersection point, the geophysical data, in this case electromagnetic induction surveys conducted for a mining company's mineral exploration program, shows a subsurface anomaly at a depth of approximately 12 meters, a void roughly 8 meters in its largest dimension, irregular in shape but substantially enclosed, connected by a narrower passage to a second, smaller void, approximately 15 meters to the northeast. The corridors themselves, when mapped at higher resolution using the LiDAR data, show a series of individual anomalous sites strung along them at intervals that are not uniform, but that show a rough periodicity of between 8 and 14 kilometers. At each of these sites, the same combination of features recurs: cleared or anomalously smooth bedrock surface, elevated position, water adjacency, astronomical alignment with solstice or equinox events, and in several cases, geophysical evidence of subsurface void spaces. The corridors extend beyond the area of detailed analysis, and the full extent of the network they suggest, if it is indeed a network, is not yet established. But the portion that has been mapped suggests a structured relationship between sites that covers a territory of roughly 40,000 square kilometers, and that is organized in a way that implies either an extraordinary series of coincidences or a planned infrastructure of some kind, oriented to celestial events and connected by waterway corridors that the channel cuts documented in other parts of the shield may have been designed to facilitate. This is the picture that emerges when you look at the Abitibi data without the constraint of the conventional timeline. It is a picture of infrastructure, not urban infrastructure, not anything that looks like what we associate with civilization in the conventional sense, but infrastructure nonetheless. A network of places that were identified, prepared, and used in relation to each other and in relation to the sky, spread across a territory on a scale that implies sustained organizational capacity over a very long period. Who had that organizational capacity, and when, and what they were doing with it, is the question that the evidence raises. without yet being able to answer. But there are traditions, scattered across the cultures, that have lived in this territory in historical times, that may be encoding the memory of an answer. The Wendigo traditions of the northern Algonquian peoples are usually discussed in the context of winter starvation psychology as a metaphorical framework for the social terror of the individual who abandons the ethic of community sharing and begins to consume others. This is a real and important aspect of what the Wendigo represents in these traditions. But the Wendigo is also, in the original forms of these accounts, before they were filtered through the lens of Western psychopathology, associated with specific places in the landscape. Wendigo territory, in the old accounts, is not everywhere. It is at specific locations, usually elevated, usually associated with water, usually described in terms that emphasize their extraordinary antiquity, their made quality, as if they were not naturally occurring features of the landscape, but deliberately constructed ones. The Wendigo, in the oldest stratum of these accounts, is not just a psychological phenomenon, it is a guardian or an occupant of specific places. Places that were made, places that carry a different kind of energy or significance than the surrounding landscape, places that the living are warned to approach with specific protocols and not to approach without sufficient ceremonial preparation. This is the structural description of a sacred site in a tradition that treats certain sites as existing in a different ontological category from the ordinary landscape. The identification of specific Wendigo-associated places with the anomalous sites that the remote sensing data is now documenting is speculative, and any researcher who makes that identification too directly risks being dismissed for conflating mythology and evidence. But the spatial overlap between the territories described in Wendigo oral tradition as places of the old power and the locations where the LiDAR and geophysical data shows the most compelling anomalies is striking enough to warrant the penned observation, even in a context where the observation cannot yet be verified. What is happening slowly in this intersection between oral tradition and remote sensing data is something important methodologically. It is the beginning of a research practice that treats indigenous knowledge not as a background source of poetic metaphor, but as a primary dataset that is being tested against and calibrated with physical evidence. When oral tradition says there is a made place at a specific location in the landscape, and the physical data from that location shows anomalies consistent with a made place, the alignment between those two sources of information is significant, even if neither source alone would be sufficient to make the case. Both together change the odds substantially. There is a moment in any investigation of this kind where you have to decide what kind of thinker you are going to be. You can be the kind of thinker who holds rigidly to the existing framework until the evidence is so overwhelming and so undeniable that the framework simply cannot survive, and you accept the revision only at that point. Reluctantly, this is what most scientific institutions ask you to be, and there are good reasons for that conservatism. Revolutionary claims made on insufficient evidence have led people badly astray throughout the history of science, and the field of alternative archaeology in particular has a long and unfortunate history of claims that turned out to be wishful thinking or outright fabrication. Or you can be the kind of thinker who follows the pattern of the evidence seriously even before the evidence reaches the threshold of proof, who commits to the investigation rather than the conclusion, who is willing to say that the pattern being observed is significant enough to warrant the sustained attention and resources that proof-level investigation would require, even knowing that the investigation might ultimately confirm the conventional account rather than revise it. The Canadian Shield anomalies, in their current state of documentation, do not prove that there was a sophisticated pre-glacial human presence in North America. They do not prove that there are artificial structures beneath the boreal forest of Ontario and Quebec and Manitoba. What they do is accumulate, in location after location, in dataset after dataset, in archival survey after archival survey, and oral tradition after oral tradition, a pattern of anomaly that keeps resisting the natural explanations that are offered for it. And the pattern is pointing somewhere specific. It is pointing toward the lakeshores, specifically toward the ancient lakeshores, the shorelines that existed during the various phases of post-glacial lake expansion and contraction, when the shield was first becoming habitable after the withdrawal of the Laurentide ice sheet, but before the lake settled into the configurations we know today. Between approximately 12,000 and 7,000 years ago, the Shield region experienced a complex series of lake-level changes, driven by the ongoing retreat of the ice and by the isostatic rebound of the crust. Lake systems that are now separate were then connected. Water bodies that are now relatively small were then enormous, covering territories that are today dry land or shallow wetland. And the shorelines of those ancient lake configurations, the places where people would have camped and lived and oriented themselves in relation to the landscape, are now either submerged under the modern lake waters or buried under meters of post-glacial sediment. The exploration of these ancient shorelines is one of the most promising frontiers in shield archaeology, not because anyone has definitively found significant structures there, but because the logic of settlement location is universal. People live near water. They always have. The most significant concentrations of human activity in any landscape are almost always associated with the places that provided the best access to water for drinking, for fishing, for transportation. On the Shield, that means lake shores. And the lake shores that were most attractive in the early post-glacial period, when the first people were moving into the newly deglaciated territory, are not necessarily the same as the lake shores that exist today. Side-scan sonar surveys of Lake Superior, Lake Huron, and their northern tributaries have already produced a body of evidence that most researchers are still not sure what to do with. Lake Superior is deep, over 400 meters in its deepest parts, and its floor preserves the sedimentary record of the landscape that existed before its basin was flooded by post-glacial meltwater. Surveys of that floor have documented linear features, ridge systems, and channel patterns that look nothing like the glacially smoothed bottom topography that characterizes most of the lake's depths. Some of these features are clearly natural, geological structures that were there before the lake existed, but some of them are not clearly natural. Some of them are too straight, too geometric, too organized in their spacing to be comfortable attributed to the geological processes that shaped the rest of the lake floor. The stone circles of Georgian Bay are perhaps the best-known example of this category of anomaly in the Great Lakes region. Georgian Bay is the northeastern arm of Lake Huron, a shallow, island-studded water body that sits at the southern margin of the Precambrian Shield. Its floor has been documented by recreational divers since the 1990s, and in at least 2 locations, divers have described encountering arrangements of large stones on the lake bottom that do not match the natural geology of the immediate area, that appear to have been assembled from stones brought from different locations, and that show weathering patterns consistent with having been on land, rather than submerged, for a substantial period before the lake level rose to cover them. The academic response to these reports has been cautious, because the history of claimed underwater structures is littered with natural features that were misidentified by untrained observers. Lake floors, particularly in glacially influenced basins, are full of glacial erratics and boulder pavements and other features that can look organized to an eye looking for organization. But some of the Georgian Bay observations come from people with sufficient geological and underwater survey experience to distinguish between a glacially deposited boulder field and something else. And what they are describing, in the accounts that hold up to scrutiny, does not sound like a glacier's work. It sounds like a circle, specifically like a series of concentric curves of stone arranged at intervals suggesting purpose rather than chance, with a cleared central area submerged under approximately 5 meters of water at their current location, in a position that would have been dry land or at the shore of a much shallower ancient lake during the period between approximately 9,000 and 7,000 years ago, when the Georgian Bay water levels are known to have been substantially lower than they are today. A circle of stones on the floor of Georgian Bay, a network of cleared bedrock surfaces and subsurface voids in the Abitibi region, channel cuts through bedrock ridges in the Nipigon Basin, stone alignments oriented to solstice horizons in northern Ontario and Quebec, oral traditions from multiple First Nations communities, describing the same features in terms that suggest knowledge of their construction and purpose that was not generated in the last few thousand years. The picture is forming slowly. It is forming from data collected for other purposes, analysed retrospectively by researchers who were not looking for what they found. It is forming in the gaps between disciplines, in the spaces where archaeology meets, geology meets, remote sensing meets, indigenous oral tradition, and none of those fields, individually, has the methodological framework to handle what is being described. That gap is beginning to close. Slowly, not inevitably, but with enough momentum that the question of what it all means is becoming one that cannot be deferred indefinitely. Let us move now to the north, because the Southern Shield anomalies, concentrated in the region where the boreal forest meets the Great Lakes watershed, are the best documented but not the only ones. And the northern anomalies, which appear in territory that is more remote, less surveyed, and historically even less accessible to conventional archaeological investigation, are in some ways even more striking. The region around Hudson Bay's western shore, particularly the area known as the Keewatin sector of Nunavut and northern Manitoba, was one of the last parts of the shield to be deglaciated, because the ice sheet had its center of accumulation over Hudson Bay and persisted in this region longer than anywhere else in the shield. The final remnant of the Laurentide ice sheet in this area, the Keewatin Ice Dome, did not fully disappear until approximately 6,000 years ago. This means that the landscape here has been ice-free for only 6,000 years, which in the conventional model makes it the youngest habitable territory in the shield, and the place where you would expect the least evidence of long-term human occupation. But the conventional model assumed, for this region, as for the rest of the shield, that no human presence predated the ice. And for the Keewatin sector, as for the rest of the shield, that assumption is being challenged. The Thelon River Basin, which drains from the central Keewatin eastward into Baker Lake and then into Hudson Bay, is one of the most remote river systems in North America. The landscape it traverses is the Barren Grounds, a treeless tundra of bedrock and gravel and shallow lakes that extends from the tree line in Manitoba north to the Arctic coast. It is cold, it is isolated, it is empty of permanent human settlement for much of its recorded history. It is also, in the testimony of the Chippewian and Inuit peoples who have travelled through it for centuries, a landscape full of things made by others before them. The Inuit term Chunit, used to describe the people who preceded them in the Arctic, is usually applied to the Dorset culture, a pre-Dorset and Dorset tradition, people who inhabited the eastern Arctic before the expansion of Thule Inuit ancestors from Alaska approximately 1,000 years ago. But in some accounts, the term is applied to features and places that predate the Dorset culture by a significant margin, and that are described in terms suggesting a degree of sophistication in their construction that the Dorset tradition, which is relatively well studied and which shows no evidence of large-scale stone construction or astronomical orientation, does not obviously account for. The Thelon River Valley contains a series of Inuksut and stone arrangements that are acknowledged as ancient even by the most conservative assessments, and that include at least two features that researchers from the University of Manitoba who surveyed the area in 2012 could not satisfactorily attribute to any known cultural tradition in the region. One is a roughly trapezoidal arrangement of stones approximately 20 meters long and 12 meters wide at the broader end, with interior divisions creating three separate compartments, oriented on an axis aligned within 1 degree of the spring equinox sunrise. The other is a single standing stone, approximately 3 meters in height, positioned on a prominent bedrock ridge, with a notch carved into its upper surface that the survey team calculated would have framed the rising of the star Arcturus from this latitude. At the heliacal rising that occurs in late spring, a notch carved into a standing stone to frame a specific stellar rising. This is not the kind of feature you attribute to chance or to natural weathering. It is the kind of feature that implies knowledge of that stellar event and deliberate intent to mark it. The question is how old it is, and the answer, based on the weathering relationships between the carved notch and the surrounding surface of the stone, is not less than 1,000 years and possibly much more. The Thelon features have not received extensive academic attention. The survey report from 2012 exists as an internal document of the University Archaeology Department that conducted the survey, and has not been published in a peer-reviewed forum. This is, again, the pattern. The anomalies get found, they get noted, they get filed, and then the momentum runs out before they can be elevated to the level of formal publication that would bring them into the academic conversation. The reasons for this pattern are partly logistical, partly institutional, and partly, it has to be said, something more uncomfortable than either of those. There is a tendency, in the discussion of anomalous evidence for pre-conventional human activity in North America, to shy away from the implications too quickly, to reach for the most conservative possible interpretation of each piece of evidence before considering what a less conservative but still evidence-grounded interpretation might reveal. This is appropriate scientific caution applied to individual pieces of evidence, but applied systematically across an entire body of evidence that consistently points in the same direction, it begins to look less like caution and more like avoidance. The anomalies of the Canadian Shield are pointing toward a revision of the North American prehistory timeline that is more radical than the shift from Clovis first to coastal migration, more radical even than the acceptance of pre-Clovis sites at 15 or 20,000 years. They are pointing toward the possibility of a human presence that goes back not into the Upper Paleolithic, but into the Middle Paleolithic, or earlier, a presence that is not characterized by the material culture typical of the mobile hunter-gatherer traditions that have been found at pre-Clovis sites elsewhere in the Americas, but by something that looks, from a distance, more planned, more organized, more oriented toward the landscape and the sky in ways that suggest a relationship with this specific territory over a time frame long enough to have produced a sophisticated understanding of it. This is a very large claim. It is larger than any researcher currently working in this field is willing to make publicly and in print because the evidence, while suggestive, is not yet at the threshold that would justify such a claim in the framework of peer-reviewed science. But it is the claim that the pattern of evidence, taken as a whole, without the constraint of the conventional timeline, is pointing toward. And it is the claim that makes the most sense of the oral traditions. Because what the First Nations oral traditions of the Shield region consistently say about the old built places is not that they were made by mobile hunters passing through. They say they were made by beings who understood this specific landscape deeply, who knew its water systems, its sightlines, its astronomical character, who built into it features that were designed to work with those specific characteristics rather than being generic or portable. This is the description of people who had been here for a very long time, long enough to know this landscape the way a doctor knows a body, with an intimacy that comes only from sustained relationship over time. The geneticist David Reich, in his work on ancient American genomes, has noted that the population history of the Americas suggests that some lineages in the indigenous populations have continuity in the Americas going back to the earliest arrivals, which his data places at more than 20,000 years ago, possibly substantially more. If some of those lineages maintained continuous presence in specific territories for that length of time, the accumulation of knowledge they would have developed about those territories staggers the imagination. 20,000 years of knowing a river system, 20,000 years of watching the sun rise and set over a specific horizon, 20,000 years of learning which rock formations provide shelter, which lake connections allow efficient travel, which elevated locations give sightlines to the features in the landscape that matter. In 20,000 years of that kind of sustained attention, a people would learn not just to live in a landscape, but to collaborate with it, to shape it in ways that would express and reinforce the knowledge they had built, mark the places that mattered, encode the relationships between those places in stone that was harder and more permanent than anything they could carry with them, or build from organic materials. The Shield, in this reading, is not a blank slate scraped clean by ice. It is a palimpsest, a surface that has been written on and partly erased and written on again, and what the remote sensing tools are now allowing us to do, for the first time, is begin to read the oldest layer of the writing. What it says we cannot yet fully decipher, but the letters are there. There is a specific set of Shield anomalies that resists even the most generous natural explanations, and it involves not stone arrangements or channel cuts or geophysical voids, but something stranger still. It involves what researchers examining high-resolution topographic data have begun calling the geometric highlands, a term that describes elevated terrain features whose profiles, when viewed from above at the resolution that modern LiDAR makes possible, exhibit geometrical regularity that is not characteristic of glacially sculpted terrain. Glacial erosion and deposition are famously variable. Ice moves in ways that produce curved forms, undulating moraines, rounded drumlins, irregular esker crests. The landscape the glaciers leave behind has a characteristic softness and irregularity that geomorphologists recognize immediately, and that is deeply different from the angular, rectilinear forms produced by most constructive processes, whether human or geological. But some of the elevated features on the shield, particularly in the transitional zone between the Abitibi lowlands and the higher ground of the Laurentian Divide, show profiles that are not consistent with glacial morphology. They are too flat-topped. Their margins are too sharp. Their plans, when viewed from above, show angles and proportions that fall outside the statistical range of natural shield terrain features of similar scale. These are the geometric highlands, and the natural explanation that is most frequently offered for them is that they are erosional remnants, fragments of harder rock that have survived while the surrounding material was stripped away, leaving isolated plateaus and mesas. This explanation works for some of them, but the ones that don't fit the erosional remnant explanation are the ones that appear to have been shaped from the outside rather than being the residual product of surrounding erosion. Their margins show evidence of material removal, scarps, and escarpments that are sharper than erosion alone typically produces, that are oriented in directions not consistent with the predominant erosion directions in the region, and their surfaces are anomalously flat in a way that erosional remnants typically are not, because natural erosion attacks the top of a feature as well as its sides and produces gently convex or rolling upper surfaces rather than precisely horizontal ones. A flat-topped feature with sharply defined, artificially oriented margins. This description should sound familiar. It is the description of a constructed platform, an earthwork or a stone-faced mound of the kind that appears throughout the ancient world, from the mounds of Cahokia in Illinois to the terraced platforms of South American civilizations, to the step pyramids of Mesoamerica, built by different peoples in different contexts, but converging on the same basic form, because that form serves a specific purpose. It is the optimal form for a large gathering place or ceremonial space that is elevated above its surroundings for visibility and for unobstructed sightlines. The suggestion that some of the geometric highlands of the Canadian Shield might be anthropogenic, might be the heavily degraded and ice-eroded remnants of constructed platforms, is one that any conventional archaeologist will reject immediately and with some force. And the rejection is understandable, because constructing platforms of that scale would imply a level of organized labor mobilization in pre-contact North America that challenges the standard narrative of pre-agricultural, pre-state societies in the region. Mound building on a large scale is documented in the archaeology of the Eastern Woodlands and the Mississippi Valley, where the Hopewell and Mississippian traditions constructed earthworks of impressive scale over several thousand years. But those traditions are well documented, relatively recent in the continental timeline, and they operated in environments with the biological productivity to support the population densities that large-scale labor mobilization requires. The Canadian Shield is not, and in the recent past was not, an environment associated with high population density. The boreal zone is ecologically productive in ways that sustain the societies that lived there, but not in the way that the rich floodplain soils of the Mississippi Valley sustained the mound-building cultures of the South. If large constructed platforms exist in the Shield, they would have been built by a population of unknown character at an unknown time, using methods that have left no clear signature in the archaeological record, in an environment that the conventional understanding says could not have supported such an undertaking. All of these objections are real, but they are all objections premised on the conventional timeline and the conventional understanding of what pre-contact North American societies were capable of. If the timeline is wrong, if there was a presence in the Shield in a period when the glacial history of the continent was different and when the ecological character of the region may have been different as well, then the objections about population density and labor mobilization need to be reconsidered. The last interglacial period, roughly 130,000 to 115,000 years ago, was a time when the Shield was not just ice-free, but was covered by a mixed boreal and deciduous forest that was ecologically richer than what it supports today. The climate was slightly warmer than the present, and the increased warmth allowed forest types to extend further north than they currently do, supporting a broader and more diverse fauna than the modern boreal ecosystem. A human population living in the Shield during the last interglacial would have had access to ecological resources that current assessments of the region's carrying capacity do not account for. This is speculative. It is explicitly speculative because there is no confirmed evidence of human presence in the shield during the last interglacial. But it represents the kind of scenario that the anomalies being documented make necessary to consider, because if the anomalies are real, and if they are anthropogenic, then the circumstances under which they were created need to be explained, and the last interglacial provides a set of circumstances in which the explanation is at least physically possible. The Milankovitch cycles that drive the ice ages are well understood and precisely dated. The timing of the last interglacial, its extent, its ecological character can all be modelled with confidence. If people were in the shield during that period, the features they built would have been subjected to everything that happened subsequently. The growth of the new ice sheet, the full weight of the glacial maximum, the scouring of the glacial retreat, the flooding of the post-glacial lakes, the stabilization of the current landscape over the last 5,000 to 6,000 years. Most of what they built would be gone. The features that survived would be those that were cut deepest into the bedrock, protected by the geometry of the landscape around them, or preserved by the same geological stability that has kept the Precambrian rock intact for billions of years. The deep cuts, the subsurface voids, the features embedded in the rock rather than sitting on its surface, these are the features most likely to have survived the full glacial cycle, and these are precisely the features that the geophysical data is documenting. There is a specific site that illustrates this dynamic with particular clarity, though identifying it precisely in this context is not possible without compromising the ongoing research and the community relationships involved. What can be said is that it is located in the Eastern Shield, in Quebec, north of the Strait Lawrence, in the territory of a First Nation that has been actively involved in a multi-year collaborative research project with a Canadian university. The site was identified initially through LiDAR analysis as a candidate location because of the combination of cleared bedrock surface, anomalous topography, and astronomical alignment that characterizes the other significant locations in the Abitibi cluster. Ground truthing of the site, which involved an expedition of community members, traditional knowledge holders, and researchers in the summer of 2022, confirmed that the LiDAR signatures corresponded to real features on the ground. The cleared bedrock area was confirmed, the topographic anomalies were confirmed, and the traditional knowledge holders identified the site as one that had been known to the community for generations, described in their oral tradition as a place of the first making, a place that predated the present world in a cosmological sense rather than simply a historical one. The geophysical survey component of the 2022 work produced the result that has kept the research team in extended consultation since. The electromagnetic induction survey at the site showed a subsurface anomaly that the lead geophysicist described in the team's internal report as the most geometrically regular natural void signature he had ever encountered in shield bedrock, but that he could not attribute to any known geological process with confidence. The anomaly is at approximately 9 meters depth, roughly oval in plan view, approximately 12 meters in its longer dimension and 8 meters in its shorter, with a ceiling that the survey models show as approximately flat and a floor that is also approximately flat. A room-shaped void, 9 meters below the surface of the bedrock, beneath a cleared and astronomically aligned surface platform, in a location that the oral tradition of the resident First Nation identifies as a place of the first making. The team has not yet been able to excavate. The community consultation process required before excavation can proceed is ongoing, and the research team respects that process, not as an obstacle, but as an integral part of what responsible collaborative research in this context requires. The excavation, if it proceeds, will be the first attempt to physically access one of the shield subsurface anomalies from an academic research context. What they find, if they proceed, may be the most important archaeological discovery in Canadian history. Or it may be a natural void that turns out to have a geological explanation that the survey data was insufficient to identify. Both outcomes are possible. The difference between being a rigorous researcher and being a wishful thinker is accepting that both outcomes are genuinely possible and not having a preference for either one that is strong enough to compromise the objectivity of the investigation. But the fact that both outcomes are genuinely possible is itself important, because 10 years ago, the subsurface anomaly at this site would not have been in a database waiting to be excavated. It would not have been surveyed. It would not have been correlated with an astronomical alignment on the surface above it, or with an oral tradition identifying it as significant. 10 years ago, the conventional framework would have ensured that nobody would look at that piece of shield bedrock and see anything other than shield bedrock. The framework is changing, slowly, imperfectly, unevenly, with significant institutional resistance at every step. But it is changing. And what the change reveals, as the accumulated anomalies come into view from multiple directions simultaneously, is not a simple revision of dates or routes. It is the outline of something much larger. It is the outline of a North American past that is deeper and richer and more complex than the civilization we have described for it. A past in which the Canadian Shield was not a blank slate but an inhabited world, shaped over very long periods by people whose relationship with the landscape was sophisticated enough to leave marks in it that even a glaciation could not fully erase. A past in which the stars that shine over the shield tonight were being watched from its surface long before any of our accepted chronologies begin. The sky itself is part of this story, and it is worth sitting with that for a moment. The night sky above the Canadian Shield, away from the modest light pollution of the small northern towns and mining camps, is extraordinary. The latitude puts you close enough to the magnetic pole that the aurora borealis is a regular presence, dancing in curtains and spirals of green and red above the boreal canopy. The darkness is complete in a way that most people living in the modern world have never experienced, and the stars, when the sky is clear, are present in a density and brilliance that makes the astronomical significance of that sky immediately and viscerally comprehensible. Any people living under that sky for thousands of years would have become astronomers. They would have had to, because the sky was their primary calendar, their primary navigational system, their primary framework for understanding the structure of time. The dramatic difference between winter and summer at shield latitudes, where the summer solstice brings nearly 20 hours of daylight and the winter solstice reduces that to fewer than 8, makes the annual cycle of the sun something that is physically lived rather than abstractly known. The solstice is not a date on a calendar, it is the turning point between the endless dark and the return of the light. It is the most important moment of the year for any people who depend on the land, because it marks the beginning of the period when the work of survival becomes incrementally less desperate. Marking the solstice in stone is not a mysterious or inexplicable behavior in this context. It is the most natural thing in the world. You mark what matters. You build the ability to predict what matters into your landscape so that the knowledge survives even when the individuals who hold it do not. You encode the calendar in rock because rock lasts, and because the people who come after you, who find the stone marks and learn to read them, will know what you knew. The astronomical alignments in the shield features are not decoration. They are technology. They are tools for precise timekeeping built into the most durable medium available. And if you accept that they are real, and the evidence for their reality is strong enough that dismissing them entirely requires a degree of motivated reasoning that becomes harder to justify as more of them are documented, then you accept that people who understood them were here. People who understood the sky well enough to build its patterns into the rock. People who cared about the knowledge surviving past their own lifetimes, past the lifetimes of everyone they knew. People who thought in the long term. People who built for permanence. People who are gone now, or perhaps not gone but present in the lineages and the traditions of those who came after them, and whose work remains in the shield bedrock, waiting for us to understand what it says. We need to talk about what is at stake in this investigation, because it is not only archaeological, and understanding why this matters beyond the narrow question of who built what in the Canadian Shield and when, is essential to understanding the kind of resistance this research faces and will continue to face. The story of North American prehistory that is currently taught and assumed, the story in which sophisticated organized human activity in this part of the world begins approximately 13,000 years ago with mobile hunter-gatherers following megafauna into an empty continent, is not a neutral scientific description. It is a narrative, and like all narratives, it serves interests as well as facts. One of the things it has historically served is the framework that European colonialism used to justify its treatment of indigenous peoples and their lands. If indigenous North Americans were simply mobile hunters with no fixed territorial relationship to the land, if they had built nothing and organized nothing, and created no enduring relationship with specific places, then there was no meaningful prior claim to the territory that European settlers were taking, or at least the prior claim could be minimized to the point where it did not seriously constrain the process of dispossession. This is history, and it is terrible history, and its effects are not past. The legal frameworks through which indigenous land rights are adjudicated in Canada today still operate within assumptions about the nature of pre-contact indigenous societies that are descended from those colonial-era narratives, demonstrating that those societies had deeper roots, more complex organization, and a more sophisticated and enduring relationship with specific territories than the conventional narrative admits, is not just an archaeological question. It is a question with direct legal and political implications for the communities whose ancestors are being discussed. This is part of why the collaborative research model, where First Nations communities are full partners in the research rather than subjects of it or bystanders to it, matters enormously. Not just as a matter of ethical principle, though it is that, but because the communities themselves have a profound stake in what the research reveals. An investigation that confirms the depth and sophistication of the human presence in the Shield, that demonstrates it was not the blank slate of the conventional narrative, is an investigation that changes the terms of the ongoing political relationship between these communities and the Canadian state. Some researchers have argued that this is precisely why the research faces such institutional resistance. Not because the evidence is insufficient, though the institutional critique focuses on evidentiary standards, but because the implications are inconvenient in ways that go beyond archaeology. A North American prehistory that includes a sophisticated, organized human presence going back tens of thousands of years before the conventional timeline is a prehistory that demands a fundamental renegotiation of whose history this is, and what claims that history supports. That is a larger conversation than the present evidence can fully drive by itself. But it is a conversation that the evidence being assembled from the Shield is beginning to force, and it is a conversation that the First Nations communities involved in the collaborative research are engaged in actively, with clarity about what they are looking for and why it matters. For the researchers working within this space, the challenge is to hold both dimensions simultaneously. The scientific dimension, where the standards of evidence and the obligations of intellectual honesty are non-negotiable, and the human dimension, where the investigation is not an abstract exercise in prehistory, but a living engagement with communities whose present circumstances are shaped by the stories told about their past. This is not easy. It is uncomfortable in ways that purely academic research is not, but it may be the only way to get the investigation right, because the knowledge that is most relevant to understanding the Shield anomalies is not all in the geophysical databases or the LiDAR datasets. Some of it is in the oral traditions. Some of it is in the relationship between specific communities and specific places that has been maintained, in some cases, for thousands of years. And accessing that knowledge requires being in relationship with the communities that hold it, on their terms, within their frameworks, in ways that respect the significance of what is being discussed. The Shield is not a museum. It is a living landscape inhabited by living peoples whose relationship with it is not broken or interrupted by the period of colonial disruption, even though that disruption was severe. It continues, transformed by everything that happened but not replaced by it. The elders who know the old built places know them because the knowledge of those places has been maintained across the generations in the form of ceremony and narrative, and the simple act of returning to them, of being present in them, of continuing the relationship with them that the builders initiated. That continuity is its own form of evidence, not evidence that any Western scientific institution will quickly know how to evaluate, but evidence nonetheless. The persistence of specific knowledge about specific places across a time period that conventional archaeology says those places were not occupied is not an accident. It is not mythological elaboration. It is, in the framework of the communities that hold it, the faithful transmission of what is known about those places across whatever interval separates the knowing from the present. The interval may be longer than we have imagined. Let us return now from the political and philosophical to the physical, because there are still aspects of the Shield anomalies that we have not fully explored, and some of them are among the strangest. The question of water. The Canadian Shield's relationship with water is fundamental to everything about it. The Shield is defined by its lakes, by the rivers that connect them, by the complex hydraulic network that drains the largest freshwater reservoir on the surface of the planet. The Great Lakes, Hudson Bay, the innumerable smaller lakes of the boreal interior, all of this water is structurally connected to the shield bedrock in ways that shape everything about what lives there and how. Any people who lived in the shield for an extended period would have developed an intimate understanding of this water system. They would have known not just the individual lakes and rivers in their immediate territory, but the larger patterns of drainage, the ways that the water moved across the landscape at different seasons, the places where the hydraulic system created bottlenecks and opportunities, the locations where the water's behavior was predictable enough to be relied upon for navigation and fishing, and the other activities that required precise knowledge of water movement. The channel cuts that we discussed earlier, the passages cut through bedrock ridges to connect otherwise separated drainage basins, make sense in this context. They make sense as navigation infrastructure built by people who understood the shield's water system in its totality and who modified specific constraints in that system to improve the efficiency of travel through it. They are not random. They are placed at hydraulic choke points, at the specific locations where a modest intervention in the natural drainage would have the maximum effect on connectivity. This is systems thinking applied to hydrology. It requires not just local knowledge of individual waterways, but a comprehensive understanding of the drainage network as a system, the kind of understanding that develops through sustained observation over multiple generations, through the accumulated mapping of water behavior at seasonal and multi-year scales that builds a mental model of the system, detailed enough to identify where strategic interventions would have the most effect. This level of understanding does not develop in a decade or a generation. It develops over centuries, through the progressive refinement of knowledge held communally and transmitted carefully from one generation to the next. The channel cuts, if they are what they appear to be, are the physical expression of a knowledge system that had reached a high degree of sophistication about the shield's water network, a knowledge system that implies a long relationship with this specific landscape. There is another water-related anomaly that has not received the attention it deserves, and it involves the behavior of the shield's water system during the period of post-glacial lake expansion that I mentioned earlier. Between roughly 12,000 and 7,000 years ago, as the ice sheet retreated and meltwater flooded the low-lying shield terrain, enormous proglacial lakes formed and then drained in episodes that sent catastrophic floods southward through the Great Lakes and into the Atlantic. These drainage events, which have been documented in the geological record, profoundly reorganized the shield's hydrology over relatively short timescales. If there were people living on the shield during this period, and the evidence for early post-glacial human presence in the region, while sparse, is not absent, they would have witnessed these events. They would have experienced the flooding of territories that had been dry land, the drowning of lake shores they had lived on, the sudden catastrophic reorganization of water systems they depended upon. And in a tradition where knowledge of the landscape is transmitted orally across generations, the memory of those events would have been maintained. There are flood traditions in the oral heritage of virtually every indigenous North American culture that has been studied. The specifics vary enormously, but the core experience, a great water that came and changed the world, submerging territories that had been inhabitable, forcing movement and reorganization, belongs to the oldest strata of oral tradition in many communities. Scholars of indigenous oral tradition have long noted that some of these flood accounts correlate remarkably well with the known events of post-glacial lake drainage and sea level change. The argument that oral tradition can preserve geologically accurate memories of events that occurred 10,000 years ago or more is now taken seriously by a growing number of researchers in both geology and anthropology. If that is right, if the flood traditions of shield communities are encoding memory of the actual events of post-glacial landscape reorganization, then the oral traditions are functioning as archives of events that occurred before the conventional timeline of human presence in the region even begins. They are describing a lived experience of the deglaciation, and if the people who had that lived experience had also built things in the shield, things that the subsequent flooding and glacial rebound and landscape reorganization then buried or submerged, the oral tradition might be encoding memory of those things as well, the places of the first making, the places that existed before the water came, the places that the old ones built and that are now hidden beneath the earth or beneath the lake. This is not mythology in the dismissive sense. This is memory in a form that is harder to read than a geological column, but potentially no less accurate about the events it records. The integration of this kind of traditional knowledge with the physical data being assembled from the shield surveys is one of the most challenging methodological tasks facing the researchers working in this space. It requires a fluency in both the scientific frameworks that govern the interpretation of physical data and the indigenous epistemological frameworks within which oral tradition is understood and transmitted, and very few people have sufficient training and relationship in both domains to navigate the integration successfully. But it is beginning to happen, and in the places where it is happening, where a researcher with geological training and a traditional knowledge holder with decades of experience in their community's oral tradition are looking at the same feature in the shield and bringing their different frameworks to bear on it simultaneously, what emerges is richer than either framework produces alone. The geologist sees an anomalous subsurface void at a specific depth in bedrock of a specific age. The traditional knowledge holder sees a place of the old ones, a location that the community has maintained ceremonial relationship with for as long as the community can remember. Neither of them alone can fully account for what they are looking at. Together, they begin to triangulate toward an understanding that may eventually be comprehensive enough to answer the most basic questions. What is it? Who made it? When? And why? The why, in this context, may be the most important question of all, because the physical features being documented in the shield are not just technologically interesting, they appear to be purposeful in a way that goes beyond simple utility. The astronomical alignments, the elevated positions with unobstructed horizon views, the association with water, the evidence of careful placement within the landscape rather than convenient or expedient placement. All of this suggests that the people who created these features were thinking about something more than shelter or navigation efficiency. They were thinking about meaning, about their relationship with the cosmos, about the structure of time and the placement of their lives within it. The features they built, if they built them, are the material expression of a worldview that was sophisticated enough to translate its central concerns into durable, precisely calibrated stone. This is what cultures do when they have the organizational capacity and the sufficient security and surplus to invest in projects that go beyond immediate survival needs. They build meaning into their landscape. They create structures that express and reinforce the knowledge they have developed about the world and their place in it, that transmit that knowledge to future generations in forms more durable than individual memory, that mark the places that matter in ways that survive the individual lives of those who made them. The question of whether the people who built the shield features had that kind of organizational capacity, that kind of security and surplus, is inseparable from the question of when they were there. In the conventional timeline, in the last few thousand years of post-glacial occupation of the shield, the ecological and social conditions that would have supported large-scale collaborative construction projects are not obviously present. The shield environment in that period supported mobile, relatively small, highly skilled, hunter-gatherer communities who were capable of extraordinary things with the resources they had, but who are not typically associated with large fixed-location construction projects requiring sustained labor over extended periods. But, in an earlier period, a period before the last glaciation, or in the early post-glacial when the proglacial lakes created a different ecological and hydraulic landscape than the one we know today, the conditions might have been different. The population densities might have been different. The social organization might have been different. The specific characteristics of the environment that supported the people who lived in it might have been different enough from what we know of the recent shield to have supported a level of activity that the recent period did not. We do not know what those earlier conditions were like in terms of human presence, because the evidence for human presence in that period, in this region, is essentially absent from the conventional archaeological record. It is absent, not necessarily because no one was there, but because the methods used to look for them have been calibrated to find the remains of mobile hunter-gatherers in post-glacial deposits, not the remains of something potentially quite different in contexts that the conventional framework did not predict were worth investigating. The remote sensing data is beginning to identify contexts worth investigating. The question now is whether the investigation will proceed with sufficient seriousness, with sufficient resources, and with sufficient methodological sophistication to produce the kind of evidence that could resolve the question definitively, rather than simply adding to the accumulation of suggestive anomalies. The archaeology of absence is a concept that does not get discussed often enough in public conversations about prehistoric investigation. The standard framing treats the absence of evidence as straightforwardly indicating the absence of whatever the evidence would have demonstrated. We found no structures, therefore there were no structures. We found no art, therefore there was no art. We found no evidence of occupation, therefore the region was unoccupied. This framing is reasonable when the absence of evidence is the result of exhaustive search in context that would preserve evidence if it existed. If you dig extensively in conditions that are known to preserve organic materials and you find nothing, the absence is informative. If you survey a landscape thoroughly with instruments capable of detecting the features you are looking for and you find nothing, the absence is informative. But if you have not searched exhaustively, if the methods available were not capable of detecting the features that would have been present, if the search was conducted in contexts that were not the right contexts to find what you were looking for, then the absence of evidence is not evidence of absence. It is evidence of the limits of your search. For the Canadian Shield, the limits of the search have been very significant. The remote sensing tools that are now documenting anomalies have only been widely available and widely applied for the last 15 to 20 years. The LiDAR datasets that cover the Shield in sufficient resolution to detect the kinds of features being discussed are largely products of the last decade. The geophysical survey data that reveals subsurface anomalies was collected for mining and geological purposes, not archaeological ones, and was not analyzed with archaeological questions in mind, until researchers began doing exactly that analysis retrospectively in recent years. Everything that has been found to date in the Shield anomaly record was found despite not being looked for, found because the data existed in archives for other purposes, and someone thought to look at it with different questions. Found because a community member or traditional knowledge holder mentioned that a specific location was known to their community as significant, and a researcher followed up. Found because a bush pilot or a trapper described something that did not fit the conventional picture, and someone made a note of it and held on to that note. This is not how comprehensive archaeological survey is supposed to work. This is serendipity compounded by persistence. And the fact that serendipity has produced this volume of anomalous observations in such a short time, from such a small fraction of the Shield's total area investigated with any degree of attention, is itself a statistical statement about what systematic investigation might reveal. The Shield covers 5 million square kilometers. The total area that has been surveyed with the methods capable of detecting the anomalies being documented, methods that were applied with archaeological questions actively in mind, is a fraction of 1% of that total. The anomalies are clustering in the small areas that have been examined. They are not randomly distributed even within those small areas. They occur in specific geological and topographical contexts that can be defined clearly enough to be predictive of where additional anomalies might be found. This means that a systematic survey program targeting the geological and topographical contexts that the existing anomalies identify as significant, applied across a substantial portion of the Shield, would almost certainly reveal more anomalies, many more. The question of how many and what they would collectively reveal about the human history of the region is unanswerable in the abstract. But the direction is clear. There are things in the Shield that have not been found yet. There are things in the Shield that the existing evidence predicts should be there, and the investigation that would find them has not yet been organized, funded, and undertaken at the scale that the question deserves. That is where things currently stand, and it is, in its way, one of the most extraordinary situations in contemporary science. Not because the evidence is dramatic in the individual case, though some of it is, but because the collective accumulation of evidence from a landscape that was supposed to be archaeologically unremarkable is pointing toward a revision of the human story in North America that would be, if confirmed at the scale the evidence suggests, one of the most significant revisions in the history of the discipline. The potential significance of what might be in the Shield is not primarily about the structures themselves, though understanding who built them and when and how would be remarkable. It is about what their existence would tell us about the deep human past in North America, about the possibility that the conventional narrative of New World prehistory, which is already being revised at its margins by the pre-Clovis evidence and the population-wide genetics, and the coastal migration models, is more incomplete than even the most revisionist mainstream researchers have publicly admitted. If there was a sustained, organized human presence in the shield at a time before the last glaciation, a presence sophisticated enough to leave engineered features in the bedrock that survived 20,000 years of ice and 3,000 years of post-glacial change, then the story of when people first arrived in North America, where they came from, what they were doing when they got here, and how their descendants relate to the societies that were in place when European contact occurred, is a story that needs to be substantially and perhaps radically rewritten. The implications are not abstract. They are carried in the bodies and communities of the millions of indigenous people whose identities and legal claims and cultural continuity are embedded in the history of this continent. What their ancestors built and how long they were here building it is not a question for academic archaeology alone. It is a question about them, about where they come from, about how deep the roots of their relationship with this land actually go. The deepest roots that the evidence is beginning to suggest are very deep indeed. Deeper than the conventional archaeology. Deeper than the conventional genetics. Deeper than the conventional timeline of human presence in the Americas has until recently allowed. And the shield, which is 4 billion years old in its bedrock, and which has been scraped and flooded and frozen and thawed and scraped again without losing its fundamental character as the enduring core of the continent, may have been holding the evidence of that depth all along. In the cuts in its bedrock, in the voids beneath its surface, in the stone circles on its ancient lake shores, in the alignments on its elevated plateaus, in the oral traditions of the people who have maintained their relationship with it through everything that the last 10,000 years have brought. The shield does not give up its secrets easily. It never has. It is hard, ancient, cold, enormous. It has been hiding under a forest for 10,000 years and under ice for 100,000 before that. It is not built to be easily read, but the tools that are now being brought to it are more powerful than anything that has been applied to it before. And the questions being asked of it, by researchers and communities working in partnership in ways that the history of this investigation has never seen, are more incisive and more comprehensive than anything that has been asked before. The answers are in the rock. They are in the deep cuts and the subsurface voids and the astronomical alignments that keep appearing in dataset after dataset. They are in the oral traditions that have been preserving their testimony for longer than we have been willing to listen. And they are slowly, through the extraordinary persistence of the people who are doing this work against significant institutional headwinds, beginning to come to light. What they will say when they are fully heard, when the investigation has progressed far enough to provide answers rather than accumulating questions, cannot be predicted. Science does not predict its own results. That is what makes it science rather than confirmation of what we already believe. The answers might confirm the most conservative interpretation of the anomalies. They might confirm a modest extension of the timeline. They might confirm something much more radical. But the questions have been asked. The investigation is underway. And the shield, 4 billion years old, and still keeping its most profound secrets, is beginning, slowly, to respond. Now let us go further into the specifics of what the rock record itself suggests, because there are aspects of the shield geology that the anomaly researchers have been paying attention to that most geological surveys have not specifically examined, and those aspects add another dimension to the picture. The Precambrian rocks of the shield are not all the same. The shield is an assemblage of different geological terrains, regions of crust with different origins and different histories that were amalgamated over billions of years of plate tectonic activity into the single stable nucleus that underlies the continent. Some of these terrains are greenstone belts, remnants of ancient oceanic crust that was scraped onto the edge of the growing continent. Others are granite batholiths, the solidified cores of ancient mountain ranges. Others are gneissic complexes, rocks that have been buried deep in the crust and heated and metamorphosed until they have lost most of the characteristics they had when they were first formed. The different terrains of the shield have different properties that would have been significant to people living on them. The greenstone belts contain metal ores, copper, and gold and nickel, and other economically significant minerals, in concentrations that have made them the focus of modern mining activity. The granite batholiths contain high-quality flint and chert in some areas, materials suitable for toolmaking. The contacts between different rock types, where the chemistry of the rock changes over short distances, are often associated with springs and water seeps, as the different permeability characteristics of adjacent rocks route groundwater to the surface. These properties would not have been irrelevant to people who lived on the shield for thousands of years. The metal ores, copper in particular, are known to have been exploited by indigenous peoples of the Great Lakes region in the Old Copper Complex, a tradition of copper artifact production that has been dated as far back as 7,000 years ago, and that represents the earliest large-scale metalworking tradition in the world. The Old Copper Complex used native copper, pure metallic copper that occurs in the greenstone belts of the Lake Superior region, which is at the southern margin of the shield. The people of the Old Copper Complex were not metallurgists in the sense of smelting ore. They were working with native metal, hammering and annealing it into tools and ornaments. But the sophistication of the old copper objects, the range of forms they take, the evidence of extensive trade networks that distributed them across much of eastern North America, shows that the people who made them were not casual or occasional users of the material. They had a deep familiarity with it and a complex cultural relationship with its production and distribution. The Old Copper Complex at 7,000 years ago is within the conventional timeline. It does not require a revision of the accepted dates of human presence in the region, but it demonstrates that people on the shield margin were engaged in organized, technically sophisticated resource extraction and long-distance exchange at a time that is older than most of the world's acknowledged civilizations. And it raises the question of what was happening in the shield itself, in the territory directly underlain by those copper-bearing greenstone belts, during that same period and before it. The anomalies being documented in the shield interior are not obviously associated with copper extraction. The channel cuts and the astronomical alignments and the subsurface voids are not located specifically in the greenstone belt terrains where copper is concentrated. They are distributed across the shield more broadly, in locations that seem to be selected for their topographic and hydraulic and astronomical properties, rather than their mineral endowment. But the existence of the Old Copper Complex at the shield margin establishes something important. It establishes that the peoples of this region, at a time that is old even by the revised standards of pre-Clovis archaeology, had the organizational capacity for large-scale coordinated activity, for the maintenance of extended trade networks, for the production of technically sophisticated material culture at quantities sufficient to be archaeologically visible. If that level of organization existed at the shield margin 7,000 years ago, what existed in the shield interior at the same time, or earlier? The Old Copper Complex is an endpoint, a documentation of what the tradition looked like at a time when it had already been developing for some period. The beginning of the tradition, the early phases of the relationship with copper, and the development of the organizational capacity that the complex demonstrates, goes back before the oldest dated objects in the archaeological record. That beginning is, as yet, undocumented, but it must have existed, and it must have developed in the context of the shield landscape, among people who knew that landscape intimately and who were developing, over the generations that preceded the Old Copper Complex, the organizational and technical sophistication that the complex represents. What they were doing in the preceding generations, and whether what they were doing left marks in the shield bedrock that the anomaly researchers are now detecting, is the question that the two bodies of evidence converge on from different directions. The copper evidence says, there were people here, organized and sophisticated, from at least 7,000 years ago. The anomaly evidence says, there are features in this landscape that suggest organized, sophisticated activity, and some of those features are too old to be the work of people here in only the last 7,000 years. The orbital that these two bodies of evidence trace around the same question is tight enough that the question is becoming unavoidable. Who was in the Canadian Shield before recorded history began, and what did they build? There are specific moments in this investigation where the evidence becomes so concentrated, so layered, that it is difficult to hold in mind as a series of individual anomalies and becomes instead a single pattern pressing against the limits of what the conventional framework can absorb. One of those moments involves the lake systems of the Central Shield and the extraordinary degree to which they appear to be organized. Not organized in the sense that individual lakes show obvious human modification, though some of them do. Organized in the larger sense, in the sense that the distribution of the most anomalously situated features across the Central Shield follows patterns that correspond to the distribution of the major lake basins and the corridors between them, as if whoever placed those features was thinking about the shield as a connected system rather than a collection of individual locations. This is a subtle point but an important one. When you place a ceremonial or astronomical structure in a landscape, the most natural thing to do is to select the best available location in the immediate area, the highest point with the best sightlines, the most prominent rock outcrop, the place that offers the most dramatic relationship between the human observer and the sky. Individual sites make sense in terms of local topography, but the shield anomalies are not just individually well placed, they are collectively organized in a way that suggests their creators were thinking beyond the individual site to the relationship between sites. The corridors that the Abitibi analysis identified, the northeast to southwest and northwest to southeast alignments along which the anomalous features cluster, are not alignments that make sense only locally. They extend over hundreds of kilometers. Following them means traversing multiple lake systems, multiple river drainages, multiple distinct geological terrains. The organization along those corridors implies a geographic consciousness that encompasses the entire region, not just the immediate locality of each individual site. The development of that kind of geographic consciousness, the ability to think about and plan across a territory hundreds of kilometers in extent, requires a specific kind of knowledge infrastructure. You need a mental model of the whole territory, not just your immediate environment. You need either a physical representation of the whole territory, a map in some medium, or an oral tradition detailed enough to transmit precise geographic information about distant places to people who have not personally traveled to those places. And you need the organizational capacity to coordinate activity across the full extent of the territory to ensure that what is built at one end of the corridor is built in a way that relates correctly to what is built at the other end. All of these requirements imply either a single organized group or a network of groups who shared a common framework for understanding and acting in the landscape. This is not the picture that is conventionally associated with the pre-contact shield interior. Mobile, flexible, kinship-based communities with sophisticated local knowledge, but without the large-scale organizational infrastructure suggested by the evidence, are the conventional model. But the conventional model, again, is calibrated to the recent period, the last several thousand years of shield occupation. The organizational infrastructure that the anomalies imply need not have been present in the recent period. It may have been present in an earlier period, before the demographic and cultural disruptions of the post-glacial transition reorganized the human landscape of the shield as thoroughly as the physical landscape was reorganized. The transition from glacial to post-glacial conditions between 12 and 7,000 years ago was not gentle. It was rapid by geological standards, though extended by human standards, and it involved changes to the shield landscape that would have been profoundly disruptive to any population living on it. The flooding of low-lying areas by proglacial lakes, the catastrophic drainage events that reorganized the lake system, the isostatic rebound that changed the drainage directions of rivers, the rapid northward shift of ecological zones as the climate warmed. All of these would have forced the people of the shield into sustained movement, disrupting the fixed relationships with specific places that the anomalies suggest were once central to their cultural life. If the organizational infrastructure associated with the anomalies was a product of the pre-glacial or interglacial period, its disruption by the deglaciation transition would explain why the conventional archaeological record, which begins in the post-glacial, does not document it. The post-glacial peoples of the shield were survivors of a catastrophic landscape reorganization, rebuilding their knowledge of a changed world from fragments of what had existed before. The oral traditions that maintain memory of the old built places may be exactly what they present themselves as, the preserved fragments of a knowledge system that was largely disrupted by the events of the deglaciation, held in memory by the communities that were its inheritors, maintained through the enormous cultural effort that oral transmission of this kind requires. This is a coherent story. It is not proven, but it is coherent, and it accounts for more of the evidence than the conventional story does. It accounts for the anomalies in the physical data. It accounts for the geographic organization of those anomalies. It accounts for the oral traditions that describe pre-existing structures in the landscape. It accounts for the deep time signatures in the genetic data. and it accounts for the pattern of discontinuity in the post-glacial archaeological record. The fact that the first well-documented cultures of the post-glacial shield look like new arrivals in a landscape they do not yet know thoroughly, rather than like people who had been there for a long time and were continuing an established relationship. The story of the shield is the story of a deep human past that was substantially erased by the last glaciation, preserved in fragments in the hardest materials available, maintained in memory through extraordinary cultural effort over millennia, and now being recovered through the convergence of remote sensing technology and collaborative research that treats indigenous knowledge as evidence rather than mythology. It is a story still being written, and the writing is happening in field notes and collaborative agreements and archival datasets and community meetings and the careful accumulation of observations that do not yet add up to a public announcement, but that are building, slowly, toward one. The announcement, when it comes, will not be a single dramatic revelation. The science of this is not built that way. It will come as a series of publications, each careful and conservative, each documenting one specific anomaly in one specific location with appropriate methodological caveats. But the cumulative effect of those publications, as they accumulate over the next decade, will be the gradual emergence of a new picture of the shield as something other than what the conventional narrative described. And when that picture is clear enough to be seen in its full extent, what will it show? It will show a landscape that was inhabited long before the conventional archaeology begins, by people who understood it deeply enough to build into it features that expressed their knowledge of the sky and the water and the rock and the relationships between them. It will show a geographic intelligence that operated across hundreds of kilometers of boreal wilderness, relating sites to each other and to the celestial mechanics that governed the passage of time. It will show an organizational capacity that produced durable infrastructure in the hardest available medium, not because it was expedient, but because it was intended to last. And it will show, woven through the physical evidence, the continuous thread of indigenous oral tradition that has been maintaining the memory of all this through the entire period that the physical evidence was hidden. The traditions that told the researchers where to look, the traditions that named the places that the data then confirmed were anomalous. The traditions that described the builders in terms that the physical evidence is beginning to validate. The shield was not a blank slate. It never was. The ice did not erase everything. The colonialism did not silence everything. The conventional framework did not prevent the accumulation of evidence that challenges it. All three of those forces were powerful, and all three of them did their damage. But neither the ice, nor the colonialism, nor the intellectual conservatism of academic archaeology succeeded in eliminating the traces that were left. The traces are there. They are in the bedrock. They are in the data. They are in the traditions. And the investigation that will bring them fully into light is underway, imperfect and underfunded, and insufficiently supported by the institutions that should be most invested in answering the question it is pursuing, but underway nonetheless. The Canadian shield is 4 billion years old, and it has been keeping its secrets for all of that time, but it keeps them in rock, and rock, in the end, can be read. We are learning to read it. There is something I want to come back to, because we have been talking about evidence and methods and timelines in ways that are important, but that risk losing sight of the human dimension. Not the political and legal human dimension, which matters enormously and which we addressed earlier, but the more intimate human dimension. The dimension of what it feels like to stand in one of these places and understand, even imperfectly and provisionally, what you are standing in. The shield at night, in midsummer, north of the tree line, under a sky untouched by light pollution, is one of the most extraordinary environments on Earth. The aurora moves in curtains above you, green and sometimes red and occasionally violet, a phenomenon that has no analogue in any other setting. The stars are more numerous than you can hold in your attention, more numerous than the darkness between them. The bedrock beneath your feet is older than anything you are likely to encounter in your daily life by an almost incomprehensible margin. Standing on it, you are standing on rock that was old before the first animal crawled out of the sea, and in certain places in the shield, you are standing on rock that people shaped, deliberately, with knowledge and intention and purpose. Rock that they cut to create passages for water or for themselves. Rock that they arranged in patterns that encoded their understanding of the sky. rock that they built into enclosures and platforms and alignments that expressed something they knew and wanted to pass on to whoever came after them, whether that was the next generation or the inhabitants of a world unimaginably distant in time. Standing in one of those places and feeling the continuity of that intention across however many thousands of years separate their making from your standing is an experience that is difficult to describe in the language of evidence and methodology. It is not mystical in any supernatural sense. It is simply the feeling of contact across time that comes when human intention is preserved in a medium durable enough to carry it to you. The same feeling you get looking at a cave painting in Lascaux, or holding a tool made by a Neanderthal, or reading words written by someone who has been dead for 2,000 years. We are in contact with something that intended to be found. That is what the shield anomalies are at their core. They are a message in the most durable possible medium, from people who understood that the rock would outlast them, who put what they wanted to say into the rock because they knew that wood and leather and fiber would not carry it across the timescale they were thinking about. They were thinking about the long future. They were building for whoever would eventually be able to read what they had written. We are beginning to be those people. We are beginning to have the tools to read what they wrote. And the reading is still in its early stages, halting and uncertain, but it is beginning. What they wrote, what the shield holds, in its cuts and its voids and its alignments, is still mostly opaque to us. We can see that something was written. We can see the general outlines of the writing. We cannot yet read the specific meaning of any given feature in the way that you read words on a page and understand what they say. But we are getting closer. The work being done now, the integration of remote sensing data and geophysical surveys and oral tradition and collaborative investigation, is building the framework that will eventually allow the reading to proceed. It is slow work, and it is uncertain work, and it is work that depends on relationships and resources and institutional support that are not always available. But it is the right work, and the people doing it are doing it with the seriousness and the care that the subject deserves. The shield will yield its secrets eventually, not all of them, not quickly, not without the sustained effort of a generation of researchers and community partners working in genuine collaboration, but eventually, and when they come, those secrets will change the story of this continent in ways that we cannot fully anticipate. The story of how long people have been here, the story of what they were capable of when they were here, the story of the relationship between the deep human past of North America and the present circumstances of the people whose ancestors lived that past. It is a story worth waiting for, worth working for, worth maintaining the curiosity and the patience to let the evidence accumulate without forcing it into a conclusion it has not yet reached. The shield is patient. It has been patient for 4 billion years. We can afford to be patient too, for the few years or decades it may take to read what it has to say. Let us look now at the specific matter of what the oral traditions say about the construction methods used for the old built places, because this is a dimension of the evidence that is rarely discussed in the few public accounts of the shield anomaly research that have appeared, and it is one that the researchers themselves find both fascinating and methodologically difficult to handle. Most of the oral traditions associated with the shield sites do not describe the construction methods in purely practical terms. They describe them in terms that embed the practical within the cosmological, that make the act of construction inseparable from the relationship between the builders and the forces of the landscape they were building in. The stone was not moved by human labor alone. The stone was moved because a relationship with the stone was established that allowed it to be moved. The channels were cut not simply by grinding and hammering, but through a process of negotiation with the rock, of establishing the correct relationship with the waterway and the land that would allow the cutting to proceed in a way the landscape would accept. This is not a description of technology in the Western sense. It is a description of an integrated practice in which what we would call technology and what we would call cosmology are not separate. The builders did not have a toolkit and a belief system. They had a unified relationship with the materials and the landscape that encompassed both practical knowledge and relational understanding, and the construction that resulted was an expression of that unified relationship rather than simply an application of technique to material. Researchers who hear this kind of account for the first time often struggle with it, because the Western scientific framework does not have a category for this kind of unified knowledge. It either treats the practical elements as the real content and the cosmological framing as metaphor, or it treats the cosmological framing as the real content and looks for spiritual or religious meaning, while dismissing the practical elements as incidental. Neither of these moves correctly handles what the tradition is actually saying, which is that the practical and the cosmological are not separable, and that the construction was an act that engaged both simultaneously. What this means for understanding the construction methods is that the oral traditions may contain accurate technical information about how things were built, but that information is embedded in a framework that the Western technical mind is not well equipped to extract without distorting it. The practical knowledge and the relational understanding are braided together in the narrative in a way that resists the kind of extraction that would produce a technical manual. You cannot take out the practical and leave the cosmological behind. They are the same thing. This is a significant methodological challenge for collaborative research, and different research partnerships are handling it in different ways. Some are focusing primarily on the physical evidence and treating the oral tradition as directional rather than technical, using it to identify where to look rather than as a source of information about what they will find or how it was made. Others are attempting a more comprehensive integration, working with traditional knowledge holders to develop frameworks for discussing the sites that do not require the separation of practical and cosmological that the Western analytical approach assumes. Both approaches have their limitations and their insights. The primarily physical approach risks confirming or denying the existence of structures without understanding their significance or their construction in terms that the tradition makes available. The more integrated approach risks producing accounts that are not legible to the academic audiences that need to engage with the research if it is to have any effect on the conventional framework. The tension between these approaches is creative and productive in the partnerships that are managing it well. In those partnerships, the physical evidence and the traditional knowledge are in genuine dialogue, each informing and being informed by the other, rather than one being used to validate the other in a one-directional relationship. The constructions that emerge from this kind of dialogue look different from the constructions that either approach would produce alone. They describe sites that have both physical characteristics, specific dimensions and orientations and materials, and relational characteristics, specific kinds of relationships with water, with the sky, with the seasonal cycle, with the people who maintain connection with them, that are aspects of the same feature rather than separate descriptions of it. Understanding this kind of description requires a different cognitive posture than the one most Western-trained researchers bring to their work. It requires holding multiple frameworks simultaneously rather than moving between them sequentially. It requires accepting that some things can be true in more than one framework at the same time without contradiction, not because frameworks are arbitrary, but because reality is complex enough to be approached from multiple directions without being exhausted by any one of them. The SHIELD research, at its best, is developing this kind of multi-framework understanding, and the picture that is beginning to emerge from it is richer and stranger and more human than the picture that either the purely physical or the purely traditional approach would produce. It is the picture of a landscape that was engaged with, over a very long time, by people who understood engagement differently from how we understand it, who did not see themselves as separate from the landscape, acting upon it from outside, but as participants in it, understanding their own activity as part of the landscape's activity rather than as an imposition upon it, who built not to dominate the landscape but to collaborate with it, to express in stone the knowledge they had developed about its character and its relationships with the wider cosmos. This is not mysticism. It is a different epistemology, a different way of knowing and a different way of acting on what is known that produced results that were functionally effective, that created water management infrastructure that worked, astronomical calendars that were accurate, navigation landmarks that were reliable across the vast, undifferentiated terrain of the boreal shield. The epistemology was different from the Western scientific one. The results were not magical. They were practical, durable, and well-suited to the landscape they were embedded in. And they may have been built by people who had been developing that epistemology in that specific landscape for much longer than we have imagined possible. The question of duration is the one that comes back again and again in this investigation, because it is the one that has the most radical implications and the least direct evidence. We can see features that look anomalous. We can see patterns that suggest organization. We can hear oral traditions that describe builders and purposes and relationships that go back beyond memory. But we cannot yet put a date on the oldest of the anomalies. We cannot yet say, with the precision that scientific publication requires, that this feature was made at this time by people of this character using these methods. The dating of features cut into Precambrian bedrock is methodologically among the most difficult problems in quaternary science. The rock itself is billions of years old and contains no datable material associated with any event more recent than its formation. The weathering of the rock surface provides some chronological information through comparative analysis, but the calibration of weathering rates in the shield is not established with sufficient precision to give the kinds of dates that would be scientifically credible without large uncertainties. Cosmogenic nuclide dating, which measures the accumulation of rare isotopes in rock surfaces exposed to cosmic rays, is the most promising technique for directly dating bedrock surfaces and is being applied at some shield sites, but it requires extremely careful sampling, and the analytical results have significant error ranges that can span thousands of years. What this means in practice is that the dating question will be answered slowly, with large uncertainties in the early estimates, and with those uncertainties gradually narrowed by the accumulation of multiple independent dating approaches at well-characterized sites. The process is painstaking and expensive, and requires the kind of multidisciplinary collaboration geochemists, geophysicists, archaeologists, and traditional knowledge holders working together on single sites over multiple field seasons that is only beginning to be assembled for the shield anomaly investigation. The first credible dates from the most promising sites may be a decade away. The comprehensive chronological framework that would fully characterize the temporal distribution of the anomalies across the shield may be 2 or 3 decades in the making. This is normal science on a difficult problem. It is not a reason to dismiss the investigation. It is a reason to understand that the investigation is at an early stage and that patience is required. But while the scientific community exercises its patience, the oral traditions have already been patient for a very long time. The communities that have maintained the memory of the old built places through all the disruptions of the last few centuries have been waiting, in their own way, for the investigation to catch up with what they already know. Not know in the sense of certainty about specific facts that can be written down and published, but know in the sense of relationship, of maintained connection with specific places that carry significance that has not been lost, even though the full understanding of that significance may have been partially disrupted by the events of colonization and forced relocation, and residential schools and all the other mechanisms through which the transmission of traditional knowledge was attacked. The knowledge that survived, the knowledge that is being brought to the collaborative research partnerships, is the knowledge that was important enough and robust enough to survive the worst that was done to interrupt its transmission. And one of the things that survived, in community after community across the Shield region, is the memory of the old built places, the specific locations, the orientation toward them, the understanding that they exist and that they matter, and that they carry knowledge that belongs to the communities whose ancestors created them and whose descendants maintain relationship with them. That survival is itself a form of evidence about the depth and significance of what the places represent. Communities do not maintain knowledge through catastrophic disruption for trivial reasons. They maintain what is essential to their understanding of who they are and where they come from. The old built places of the Shield, in the traditions of the communities who know them, are essential in exactly this sense. They are part of the answer to the question of who these peoples are, where they come from, how long they have been here, what their ancestors understood about this land, and the investigation that is now beginning to locate those places in the physical record, to document their features, to begin the slow work of dating and characterizing them, is the first step toward an answer that the communities themselves have known how to ask for a very long time. Let us speak now about the comparisons that force themselves on anyone who has spent time with this material, not the comparisons that the fringe archaeology tradition loves to make, the sensational ones that reach for pyramids and lost continents and global civilizations. Those comparisons obscure more than they reveal. The comparisons that matter here are more specific and more grounded. They are comparisons with what we know happened in other parts of the world, in similar timeframes, with similar kinds of peoples, in similar ecological contexts. Because the Shield is not the only ancient landscape where careful analysis of surface features and geophysical data has begun to reveal anomalies that the conventional archaeological narrative was not prepared to accommodate. The Australian outback, which is underlain by ancient Precambrian rock, not unlike the Canadian Shield in its geological character, has been producing evidence of organized human activity at great depth of time for longer than the Shield investigation has been underway. The sophisticated stone arrangements and astronomical alignments associated with Aboriginal Australian culture have been documented for decades, and some of them are now thought to be far older than was originally assumed, with recent dating pushing some complexes back well beyond 40,000 years. The oral traditions associated with these features, which are even more precisely maintained and transmitted than the Shield traditions, because the disruption of colonialism, while catastrophic, did not fully succeed in breaking the lines of knowledge transmission, describe a relationship with specific features of the landscape that goes back to the time of the dreaming, a time frame that in the Aboriginal cosmological framework is not mythological but geological, the deep time of the continent's formation. The comparison is not to claim that the Shield and Australia represent the same tradition or the same people. They clearly do not. But they represent the same general phenomenon. Ancient landscapes, inhabited by ancient peoples who developed sophisticated understandings of those landscapes and expressed those understandings in durable forms that have survived into the present. And they demonstrate that the conventional assumption that organized, sophisticated engagement with landscape was limited to the historically documented agricultural civilizations is wrong. It was not limited to those civilizations. It preceded them by a very long time in multiple locations around the world. The Shield is one of those locations. The evidence that it is one of those locations is, as of this writing, less developed than the Australian evidence. But it is moving in the same direction with increasing speed, and the methodological lessons learned in the Australian context are being applied in the Shield research with explicit awareness of the comparison. What the Australian example demonstrates most powerfully is that oral tradition can preserve geographically and astronomically accurate information for extremely long periods of time. The Aboriginal oral traditions that describe the features of the landscape in terms that correspond to the geological and astronomical record with remarkable precision, traditions that have been maintained through oral transmission for tens of thousands of years without the support of writing or other external recording media, are the most dramatic demonstration of this capacity available in the ethnographic record. If the Aboriginal traditions demonstrate what oral transmission of landscape knowledge can achieve over very long periods, the Shield oral traditions are operating within the same general framework of capacity. They may be preserving information that is thousands of years old, or tens of thousands. They may be the last accessible link to a knowledge system that the physical evidence suggests was sophisticated and widespread in the Shield region at a time that the conventional archaeology does not account for. This is not certain. It may be that the Shield traditions are newer than they appear to be, that they encode knowledge developed in the post-glacial period by peoples who did not build the anomalous features, but who discovered them and incorporated them into their cosmological framework. This is a real possibility, and the research must remain open to it. The discovery of pre-existing structures by later inhabitants, who then incorporated them into their own cultural practice, is not unusual. It is essentially what European peoples did with Stonehenge for most of the last 2,000 years. But even if the Shield traditions are encoding knowledge of discovery rather than creation, the physical features they are pointing to remain to be explained. They remain anomalous. They remain outside the geological and archaeological record, and explaining them requires, at minimum, acknowledging that someone was in the Shield before the peoples whose traditions are guiding the current research, building things in rock that have survived into the present. Who that someone was, and what exactly they built, and why, remains to be determined. The investigation is underway. The evidence is accumulating. The framework for understanding it is being built, painfully, slowly, and against considerable resistance, by the people who have chosen to take the anomalies seriously. The night is long on the Canadian Shield. In winter, the sun sets at 3 in the afternoon and does not rise again until 9 in the morning. The darkness lasts 18 hours, and in that darkness, the stars and the aurora are the only light. Any people who wintered in this landscape would have had those 18 hours of darkness to think, to talk, to tell stories, to look at the stars. And over the many thousands of winters that the evidence suggests people have been here, the 18 hours of darkness would have accumulated into an extraordinary inventory of thought. The inventory is not lost. It is in the rock and in the traditions, and the people who are learning to read it are doing the most important work in Canadian archaeology. They are reading the oldest book, and the book is beginning to yield. There are specific details about the shield anomaly sites that become more comprehensible when you understand something about the behavior of the aurora borealis and its relationship to the geomagnetic field. This may seem like a digression, but it is relevant to one of the most persistent puzzles in the site distribution pattern. The most dense clustering of anomalous sites in the existing documentation does not correspond precisely to the best topography for astronomical observation, or to the most accessible waterway corridors, or to the richest mineral endowments. It corresponds, with a consistency that has puzzled several researchers who noticed it, to regions where the geomagnetic field shows elevated local variability due to the magnetic properties of the underlying Precambrian rock. The Canadian Shield, particularly in its greenstone belt terrains, contains abundant magnetite and other magnetic minerals that create local perturbations in the Earth's geomagnetic field. These perturbations are large enough to deflect compass needles by several degrees and are well documented in the magnetic surveys conducted by geological agencies. In many parts of the Shield, the magnetic landscape is as complex and as geographically distinctive as the physical landscape. The aurora borealis is a geomagnetic phenomenon. Its distribution in the sky and its intensity at any given location are functions of the geomagnetic field structure, both the large-scale planetary field and the local perturbations created by the magnetic properties of the underlying rocks. In regions where the local magnetic field is elevated by crustal magnetism, auroral activity is often intensified, with more frequent, more intense, and more geometrically complex displays than in magnetically quieter regions. The correlation between the dense clustering of shield anomalies and the magnetically elevated terrains suggests that the people who used and built these sites had noticed the relationship between the local geology and the behavior of the clust aurora, and that they chose, or established, their most significant sites in the places where the aurora was most dramatic, most complex, most likely to produce the extraordinary visual displays that anyone who has seen a strong auroral event in the Shield Wilderness understands to be among the most powerful natural phenomena on Earth. This is speculative. The correlation is real, but its interpretation is not established. But it suggests something about the sensory and experiential world of the people who built these sites that the purely technical analysis of features and alignments does not capture. They were not only astronomers in the technical sense, tracking the position of stars and sun and moon with precision sufficient to encode the results in durable stone. They were also living in and responding to a visual environment of extraordinary richness and drama, one in which the sky was not just a background for the practical business of celestial timekeeping, but an active, dynamic presence that produced phenomena of terrifying beauty on a regular basis. Building your most significant sites in the places where the aurora was most intense was not irrationality. It was the expression of a relationship with the sky that went beyond the practical and into the experiential, the aesthetic, and possibly the spiritual in the broadest sense of that term. It was the recognition that certain places in the landscape had a character, a quality of experience associated with them that went beyond their topographic or hydraulic or astronomical properties. They were places where the sky was most present, where the relationship between the landscape below and the cosmos above was most direct and most legible. And that quality of presence, of the sky being available in a way it is not everywhere, may be one of the things the oral traditions are encoding when they describe the old-built places as places where certain relationships with the larger world were accessible. Not metaphorically, actually, because the aurora is actually more intense in those places. The magnetic landscape that the traditions describe in relational terms is actually different there in ways that produce real differences in the visual and sensory environment. The traditions are accurate. They are just accurate in a language that the Western scientific framework has not, until recently, been equipped to translate. That translation is beginning to happen, And the shield, which has been waiting with the patience of 4 billion years for someone to read it correctly, is beginning to respond. It is speaking in the language of geophysical anomalies and LiDAR shadows and the oral traditions of the peoples who know it best. And what it is saying, slowly, incompletely, in the halting vocabulary of an investigation that is still in its early stages, is something that the conventional narrative of North American prehistory was not prepared to hear. It is saying that it was not empty. It was never empty. It was full of people and knowledge and intention and construction and relationship with the land and the sky and the water, for much longer than anyone who did not grow up knowing the old stories has been willing to admit. The stories knew, the rock knew, the anomalies knew. We are only now beginning to catch up. The final thread in this story that needs to be followed is the one that leads forward rather than backward, because the Shield anomaly investigation is not only about the past, it is about what happens next, about how the investigation proceeds, and what kind of infrastructure supports it, and what institutional frameworks govern it, and what the relationship is between the communities whose heritage is at stake and the researchers and agencies whose involvement is necessary for the investigation to advance. This is partly a funding question. Systematic, multidisciplinary, collaborative archaeological investigation at the scale that the Shield requires is expensive. The LiDAR surveys, the geophysical ground truthing, the cosmogenic nuclide dating, the archival analysis, the community engagement processes that are the ethical foundation of the work, all of these require sustained financial support of a kind that is not currently available from any single source. The Canadian Academic Research Funding System, administered primarily through the Social Sciences and Humanities Research Council and the Natural Sciences and Engineering Research Council, is not configured to fund this kind of investigation at the scale and with the methodological flexibility that it requires. The existing archaeological research funding frameworks were designed for conventional archaeological projects in known cultural contexts, not for the kind of multi-framework, multidisciplinary, community partnership investigation that the Shield anomalies are demanding. There have been discussions among researchers and community partners about alternative funding models, including Indigenous-controlled research funds and collaborative agreements with mining and resource companies, whose exploration activities generate the geophysical data that is one of the primary inputs to the investigation. These discussions are ongoing. They have not yet produced the comprehensive funding framework that the investigation needs. But the conversations are happening, and the communities that have the most at stake in the investigation's outcome are increasingly involved in shaping those conversations. This is as it should be. The communities whose ancestors built, or found, or maintained the old built places have the deepest interest in understanding them. Their involvement in designing the research framework, not just as subjects or consultants, but as co-investigators with the authority to shape the questions being asked and the methods being used to answer them, is not just an ethical requirement, it is a practical one, because the knowledge they hold is essential to the investigation in ways that external researchers cannot replicate. The protocols for this kind of collaborative research are still being developed. There are models to learn from, including the Australian context and various North American Indigenous archaeology frameworks that have been developed over the last 30 years. But the Shield context has its own specific character, its own history, its own communities with their own priorities and relationships, and the protocols that work here need to be developed in and for this context, rather than imported wholesale from elsewhere. What the research community can offer, at its best, is technical expertise, access to databases and analytical tools, and the credibility within the academic framework that is necessary for research findings to influence the institutional understanding that currently underlies Canadian policy regarding Indigenous heritage. What the communities can offer, at their best, is directional knowledge, relational access to the sites and the traditions associated with them, and the authority to determine what research is appropriate and how its findings should be communicated and used. The partnership that integrates these offerings without instrumentalizing either party is the goal. It is not always achieved. The history of the relationship between Indigenous peoples and academic research in Canada is complicated enough that trust is not given but earned, slowly, through demonstrated respect and reciprocity. The researchers who have made the most progress in the shield investigations are, without exception, those who have prioritized the relationship building that makes trust possible over the pace of data collection that their academic frameworks reward. This is another reason why the investigation is slow, not only because the technical work is slow, though it is, but because the human work, the work of building the trust and the relationships and the shared understanding that makes genuine collaboration possible, takes time that the academic calendar and the funding cycles and the publication metrics do not easily accommodate. But the human work is the foundation of everything else. Without it, the investigation cannot access the knowledge and the locations that are essential to its progress. With it, the investigation gains access not just to specific sites, but to a worldview that has been developing its understanding of those sites for longer than the academic tradition has existed. That is not a small thing. That is, perhaps, the most significant resource available to this investigation. And the researchers who understand that are building something that is bigger than any individual discovery, bigger than any paper in any journal, bigger than the conventional framework they are working to revise. They are building a new way of doing this kind of research, a way that is collaborative rather than extractive, that holds multiple knowledge systems as equally valid rather than privileging one over the others, that understands the investigation of the past as inseparable from the relationships with the communities whose past is being investigated. This is the methodology that the shield anomalies are demanding, not because it is the most efficient path to publication, because it is the only path to truth. The shield is patient, the traditions are patient, the rock is patient, and the investigation, with all its complications and its slowness and its methodological novelty, is patient too. What it will find, when it has the time and the resources and the relationships to look properly, will be worth the patience. Now let us bring this journey toward its ending, not because the investigation is ending, it is just beginning, but because there is a particular quality of the shield landscape that belongs to this kind of narrative, and that quality is the quality of dusk. Dusk in the shield, in the boreal interior, in summer. The sun has been above the horizon for 17 hours, and it is finally beginning to approach the northwest in its long, shallow descent. And the light on the water of the lake you are sitting beside is doing what shield light does at that hour, going golden and then rose, and then a deep copper that turns the lake surface into hammered metal. The spruce and tamarack at the water's edge are silhouettes. The loon that has been calling all afternoon has gone quiet. The first stars are beginning to appear in the east, above the tree line. Behind you, the granite bedrock of the shield, bare and ancient, holds the warmth it has been collecting all day and releases it against your back in the cooling air. In this landscape, at this hour, the distances between past and present narrow, not because there is anything mystical about a shield sunset, though it is beautiful enough to seem so, but because the landscape itself provides such continuity between the human past and the human present. The same rock, the same water, the same stars, beginning to appear above the same tree line, the same quality of light on the lake that every human being who has ever sat by this water in summer has seen. The people who built the features that the LiDAR data and the geophysical surveys are documenting sat in this light too, sat by this water or water like this, watched these stars appear, felt this rock warm beneath them. Whatever they knew, whatever they understood about this landscape and the sky above it and the water threading through it, they knew it in this light. We do not yet know who they were in any complete sense. We do not know their names, their languages, their social organization, their beliefs, the specific content of what they understood and expressed in the features they left in the rock. We have the outlines. We have the anomalies. We have the oral traditions that point toward them. We have the beginning of an investigation that may, in a decade or a generation, begin to fill in the outlines. What we know now, sitting with the accumulated evidence of this investigation, is that they were here for a very long time, that they understood this landscape with a depth that comes only from sustained, multi-generational relationship, that they built their understanding into the rock because they wanted it to last. It has lasted, and we are, finally, beginning to look. The boreal forest is vast, and the shield beneath it is vaster still. The lakes are more numerous than there are words in most languages to count. The rock is older than the first animal and will be standing when the last one is gone. And somewhere in that rock, in cuts and voids and alignments that the LiDAR and the geophysicists and the traditional knowledge holders are only beginning to map, is the record of a human presence so old that its full extent can barely be imagined. Old knowledge in old rock, under old trees, beside old water, beneath a sky whose stars were old when the first of us arrived to watch them. And still the aurora comes, as it always has, green fire on the geomagnetic wind, curtaining the northern sky above the shield, illuminating in its cold light the landscape that holds its secrets in the bedrock, waiting for the investigation that is finally, against all the institutional resistance and the methodological difficulty and the complexity of the human relationships involved, beginning in earnest. The secrets are there. The investigation is underway. What happens next is the story that has not yet been written. But the opening chapters are extraordinary, and the shield is not finished speaking. It has barely begun. Let me tell you one more thing before we come to rest in this subject, because there is a specific phenomenon in the shield investigation that serves as a kind of symbol for the whole enterprise, and it belongs in this account. When the glaciers retreated from the shield, they left behind a landscape that was, in places, scoured completely to bare bedrock, stripped of every trace of soil or organic matter, reduced to the hard mineral surface of the Precambrian. On those bare surfaces, over the thousands of years since deglaciation, lichens have been growing. Slowly, almost imperceptibly slowly, the same species of lichen have been colonizing the same surfaces, forming circles and patches and irregular masses of grey and green and orange. Their growth rates so consistent and so predictable that geologists use them as a dating tool, a technique called lichenometry, to estimate the age of rock surfaces by measuring the size of the oldest lichen colonies present. Lichenometry is not a precision instrument. Its error ranges are large, and it is useful for rough estimates rather than precise dates. But it has demonstrated, across decades of application, that certain surfaces on the shield have been exposed since deglaciation, a consistent story of age that the lichen themselves are living testimony to. Now, the anomalous stone features in the shield, the upright stones and the cleared surfaces and the modified rock faces, show lichen colonization patterns that in many cases are inconsistent with what would be expected if those features had been created in the post-glacial period and had been continuously exposed since creation. The lichen patterns suggest, in multiple cases, that the surfaces in question were not continuously exposed from the post-glacial, but were either covered for a period and then re-exposed, or were exposed later than the surrounding bedrock, or show patterns of differential colonization that are most consistent with surfaces that have been artificially cleared at some point during the post-glacial. This is not decisive evidence for anything in particular. Lichen patterns are complex, and the factors that influence them are numerous enough that anomalous patterns can have many causes. But the lichen evidence is consistent with the general picture being assembled from the other lines of evidence. It is consistent with surfaces that were modified or cleared by human activity at some point during the postglacial period. It is consistent with features that have a history distinct from the surrounding bedrock. And in several cases, it is consistent with features whose surface exposure history is more complex than simple continuous exposure from deglaciation would produce. The lichen, the smallest and most patient of living things, growing their slow circles on the shield bedrock at a pace so deliberate that geologists use them to measure time, are adding their testimony to the accumulating record. Even they have something to say about what happened here. And what they say is, this surface is different. This surface has a history that the surrounding rock does not share. This surface was touched by something that the untouched rock was not. The record is in the rock, it is in the water, it is in the oral traditions, it is in the geophysical data, it is in the genetic record of the peoples who have maintained relationship with this landscape through everything that the last 10,000 years have brought. It is in the lichen growing in patterns that tell their own slow story of exposed surfaces and covered surfaces and the complex history that lies between. It is everywhere for those who know how to look, and more people are learning. There is a particular quality to the knowledge that has been accumulated in this investigation, a quality that is worth naming before we leave it. It is the quality of converging lines. not the single line of a conventional historical argument that builds from premises to conclusions through a chain of documented steps, each one traceable and verifiable, each one either standing or falling on its own evidential merit. The Shield investigation does not have that kind of linearity yet, and may not have it for many years. What it has instead is a cloud of observations from different directions, each imperfect and provisional in itself, none individually sufficient to establish what they are collectively suggesting, but collectively pointing towards something with an urgency that the imperfection of each individual line cannot diminish. It is the convergence of the imperfect lines, not any single definitive observation, that constitutes the case. This is not unusual in science at the frontier. The history of knowledge is full of cases where the evidence for a major revision of the existing framework was, for years or decades, exactly in this condition. Numerous imperfect observations from multiple independent sources, all pointing in the same direction, each individually explicable by alternative hypotheses, but collectively resistant to any alternative account that did not require an implausible number of independent coincidences. The theory of plate tectonics was in this condition for decades before it was accepted. The Clovis first model of American prehistory was in this condition for decades before it began to yield. The evidence for the population Y genetic signal was in this condition before the publication of the 2015 paper that identified it. The Shield anomaly evidence is in this condition now, not at the stage of a 2015 paper that crystallizes the converging lines into a publishable argument that forces the academic conversation to engage, but building toward that stage, accumulating the observations and the relationships and the methodological frameworks that will eventually allow the crystallization to happen. When it happens, the conversation it forces will be large and contentious and important. It will require Canadian archaeologists and anthropologists and geologists and geneticists to engage with evidence that challenges the assumptions their fields have been organized around for generations. It will require government agencies responsible for Indigenous heritage and Indigenous land rights to reckon with the implications of a much longer and more complex First Nations presence on the Shield than the existing frameworks. Acknowledge. It will require a public reckoning with the fact that the conventional narrative of North American prehistory, already being revised at its edges by pre-Clovis discoveries and coastal migration models and genetic complexity, may require revision at its center as well. None of this will be comfortable. Major revisions of major narratives never are, but the discomfort is not a reason to avoid the revision. It is a reason to prepare for it carefully, to build the evidence base and the methodological framework and the community partnerships that will allow the revision to be made responsibly rather than sensationally, grounded rather than speculative, accurate rather than satisfying. The researchers who are doing this work understand that. The community partners who are shaping it understand that. The investigation is proceeding with the seriousness that its subject demands. And the Shield, which has been waiting for a very long time to be read correctly, is not going anywhere. It will be here when the investigation is ready to advance. It has been here for 4 billion years. It can wait a little longer. But the people who care about what it holds are not waiting passively. They are in the field. They are in the archives. They are in the community meetings. They are building the relationships and developing the methods and accumulating the observations that will eventually allow the waiting to end and the telling to begin. And when it begins, when the full story of what the Shield holds can finally be told in a way that the evidence supports and the communities endorse and the academic framework can accommodate, it will be one of the most important stories ever told about the human past on this continent. A past that is longer and deeper and richer and more intentional than anyone who accepted the conventional timeline could have imagined. The Canadian Shield, the oldest landscape on Earth, the core of a continent, the repository of a human presence so ancient that the ice covered it and the evidence was buried, and the oral traditions were the only thread that held the knowledge to the present. That thread held, and the evidence is surfacing, and the story is coming. It is almost time to close this account. But there is one more dimension to sit with, the dimension that is the hardest to talk about and the most important to not leave out. The dimension of what this means for how we understand ourselves. Not ourselves as Canadians, or as Indigenous peoples, or as members of any particular community or tradition. Ourselves as humans. As the species that has been on this planet for 300,000 years, that has occupied almost every environment the planet offers, that has developed the capacity for abstract thought and complex language and cumulative knowledge and the building of meanings into the landscape that outlast individual lives. The shield anomalies, if they are what the evidence suggests, expand the demonstrated range of that capacity in time. They push back the moment when we can document organized, sophisticated, intentional engagement with the landscape and the sky in North America from the period of the well-known pre-contact cultures, which are themselves extraordinary in their sophistication, to a period that the conventional framework would not have predicted. This does not change what humans are, but it deepens our understanding of how long we have been what we are. The capacity to build astronomical calendars in stone, to engineer water systems across hundreds of kilometers, to maintain knowledge of those systems across generations through sophisticated oral tradition, to understand the geomagnetic landscape and place your most significant sites where the aurora would be most intense above them. These are not recent capacities. They are ancient capacities, demonstrably ancient in the African and Eurasian context, and now, if the shield evidence is read correctly, demonstrably ancient in the North American context as well. We have been this kind of creature for a very long time, looking at the stars, reading the landscape, building our understanding into the hardest available material, maintaining the knowledge through the catastrophes that threaten to break it. The shield is one place where that ancient capacity left its record, a record that is now beginning to be recovered. The recovery is the work of our moment, and the people doing it, in the field and in the archives and in the community halls, are doing something that matters at exactly the level that the depth of human history matters. They are reading the oldest book on this continent, and what it says, when it can finally be fully read, will change how we understand who we are and how long we have been here and what we were capable of long before the histories we know began. The stars are out now over the shield. The aurora is beginning in the northeast, a pale green shimmer above the tree line that will build over the next hours into something that has no adequate description in language. The lake is still, the spruce are silhouettes. The granite beneath it all is breathing, infinitely slowly, the long breath of a landscape that is still rebounding from the weight of ice that was gone 10,000 years ago. And somewhere in that granite, cut into it, shaped by it, encoded within it, is the record of the people who were here before us. Before all of us, in the sense that matters for this story, before the conventional timeline begins, before the framework that shapes our understanding of this continent was established. They were here. They built things. They understood the sky and the water and the rock with an intimacy that came from a relationship measured not in years or decades or centuries, but in something much longer. And they put what they knew into the rock, because the rock lasts. It lasts, and so does the knowledge. It is waiting to be found. The outro to a story like this one cannot be a summary. Summaries flatten what has to remain multidimensional. They close what needs to stay open. They resolve what needs to remain unresolved, because the resolution has not happened yet. The investigation is underway, and its conclusions are not in. The anomalies are documented, but not dated. The oral traditions are preserved, but not fully translated into the framework that would make them legible to the institutions that need to engage with them. The collaborative research partnerships are being built, but are not yet at the scale and with the resources that the investigation demands. What this story has is not a conclusion. It has a direction, a momentum, a set of observations that point somewhere, clearly and consistently, even though they cannot yet tell you exactly what they have found at the place they are pointing toward. And it has a feeling, the feeling you get when you have been walking towards something in the dark for a long time, and you are beginning to see its outline ahead. You cannot make out the details yet. You cannot tell exactly how large it is or what its surface looks like up close. But you can see that there is something there, something that was not visible before you started walking, something that will be much clearer when you get closer. The researchers who are doing this work are walking toward that outline. They have been walking toward it for years, in some cases for decades, against institutional headwinds and funding scarcity and the specific discomfort of doing work that challenges the frameworks of the fields they were trained in. They are walking toward it in partnership with communities that have their own profound reasons to want the investigation to succeed, and their own profound reasons to be cautious about how it is conducted and what is done with what it finds. The walk is far from over, the outline is still dim, but it is there. And if you lie awake tonight thinking about the shield, if the image of those cut channels in the Nipigon Basin stays with you, or the geometric void 9 meters beneath the cleared bedrock surface in Quebec, or the stone alignment oriented within 2 degrees of the winter solstice sunset in northern Ontario, then you are sharing the feeling that keeps the researchers walking. The feeling that there is something there, something real and old and extraordinary and still, almost entirely, unknown. Something in the rock, something that the ice could not erase, something that the oral traditions have been pointing toward for as long as the oral traditions have existed. The Canadian Shield keeps its secrets in the hardest material on the surface of the Earth, 4 billion years old and still standing, scraped by ice and flooded by meltwater and slowly rebounding toward the sky, and still holding, in its cuts and its voids and its alignments and its anomalies, the record of a human presence that the conventional account of this continent's history has not yet learned to see. The account is changing, slowly, imperfectly, with all the resistance and the complexity that major revisions of major narratives always attract. But it is changing, and the shield is waiting. Patient as 4 billion years of waiting makes you. Patient as rock. It has time. The question is whether we do. Whether the investigation will receive the support it needs in the time frame that the communities whose heritage is at stake deserve. Whether the knowledge held in the oral traditions will be met before the generations that carry it most completely are no longer with us, by an investigation sophisticated enough to translate it into the physical record in ways that the institutional framework can engage with. It does matter. The shield matters. The knowledge it holds matters. The communities that have been maintaining that knowledge through everything done to interrupt its transmission matter profoundly, and so does all the work now beginning in earnest to read it. We are barely at the beginning of that reading, but we have started, and the shield has started speaking. Listen, it is saying something very old, something that was old when the first ice came and covered it, something that survived the ice, something that is still here, still waiting. And if you are watching this as the night deepens around you, if you are somewhere in the world where the screens are dimming and the hours are late and the sound of this is carrying you towards sleep, then you are doing something your ancestors have always done. You are listening to a story about where we come from and who was here before us and what marks they left on the landscape. You are doing what human beings have always done in the quiet hours, when the business of the day is finished and the mind is loose enough to drift toward the deep questions. Who was here? How long ago? What did they know? What did they build? The shield holds the answers in its rock. The traditions hold the answers in their memory. The investigation is learning to translate between the two. The night is long on the shield. The stars are out. The aurora is building in the north. Green fire on the ancient geomagnetic wind. The lake is still. The spruce are dark against the sky. And in the rock, patient as the rock itself, the oldest book on this continent is waiting for the next line to be read. Sleep well. And if you found yourself moved by this investigation, by this journey through the oldest landscape on the continent and the deepest mysteries it holds, you can tap the like button softly. The way you close a book you are not ready to finish. You can subscribe if you want to keep exploring these hidden corridors of history and science and the strange, ancient questions that the physical world keeps pressing against the limits of what we think we know. Leave a comment if the mood takes you. Tell me where you are right now, what time it is where you are sitting or lying in the dark. Someone in a northern Ontario town where the shield is visible out the window. Someone in Montreal or Toronto or Vancouver, or a place much further from the boreal forest than any of those. All of you connected to the same story that the rock has been keeping for 4 billion years. I read every comment, and there is something that will never get old about knowing that the same questions are finding the same listeners across all the distances of the world. If you want to support this work in a deeper way, there is a membership option here on the channel, completely optional, a way to keep these long explorations going for as long as they are needed. But your presence here, your willingness to follow a story into the long dark of the oldest geological formation on Earth, is already more than enough. Rest now. Let the shield be in your mind the way it is in reality. vast and old and mostly still unknown, and full of something that is waiting to be found. Let the aurora move in your imagination the way it moves in the northern sky. Let the lake be still. Let the rock breathe its slow, ancient breath beneath everything. There is something very old in the ground beneath this continent, and we are learning to hear it. Good night.